In the year 2000, Awqaf South Africa was pioneered as an institute of Awqaf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and In the year 2000, Awqaf South Africa was pioneered as an
Many who struggled with maths found a guiding light in William Smith's teachings. His work empowered students to overcome challenges, achieve academic success, and pursue careers they once thought were beyond their reach. Many have gone on to become engineers, computer scientists, and other professionals who credit their success to William Smith's teachings. At Awqaf SA, we are inspired by William Smith's dedication to education. We continue his mission to empower learners across the nation with our maths upgrade programs, ensuring a bright future for the youth of South Africa. Rest in peace, William Smith. You have served our country with distinction. Your legacy will continue to inspire and uplift generations to come.
Here we go.
That's how we start the morning. A warm welcome to one and all. Assalamu alaikum. Ahlan wa sahlan. One kili kili. Welcome to Al Azhar High School. We'll be hosting the grade 10 maths workshop. We will be focusing on maths paper 2. We will be speaking to some of the educators here at Al Azhar. We'll be calling on Mr. Mani shortly to give a few words by way of introduction. To all our subscribers and participants that have logged on online, a warm welcome to you. Please let us know in the comments from which schools you are connecting to us from, as well as your province. We'll appreciate your feedback during the course of the day. And I don't know, I think we could be celebrating a milestone of 7,000 YouTube subscribers. Please do like this maths video, share it. Sharing is caring. Share it with your network of learners at school. In this way, we may provide support for a wider network of learners. So we are here at Al Azhar High School. We've got a group of geniuses here. We've got potential scientists, politicians, accountants, doctors, and some of the great minds that's going to solve some of the challenges that South Africa does face. So we have Mr. Kota. He's the maths facilitator. He will be taking us through maths paper 2 today. You can refer back to these videos. We conducted a workshop where we dealt with maths paper 1. All of this information can be found on Awqaf's YouTube platform, Awqaf South Africa. So this project is hosted by Awqaf in a partnership with the Department of Basic Education, the Thread Awqaf iSkill, Mr. Kota's maths institution, and this can only be possible with a partnership with some of the schools that host these workshops. So I would like to call on Mr. Ashik Mani just to give us a few words by way of introduction. He's been instrumental in activating this program. Oh, I don't see him around. So if we can get Mr. Mani, we'll appreciate a few words by way of introduction. In the meantime, let's give introduction to Mr. Kota. He'll be the maths facilitator for today. Mr. Kota has been the implementing agent for our maths workshop since 2016, and he is involved in assisting learners with their mathematics in terms of tuition and also preparing them for battlefield. You go to battlefield when you do kind of go through your examination. So Mr. Kota has a combination of book-wise knowledge of mathematics as well as streetwise knowledge of mathematics. He's going to show you the shortcuts and show you which rules you can break and some of the concepts to get a deeper understanding of it. So here we go. Here's Mr. Ashik Mani. He's the principal of Al Azhar High School, and he'll be giving us a few words by way of introduction. Mr. Mani, are you excited for the session today? Are you pumped?
Inshallah, the energy must build up now. It's cold. Inshallah. But yesterday you did well. Shukran. And Assalamu alaikum, everybody. Wa rahmatullahi wa barakatuh. Today is going to be day 2. So you have completed a maths course. Day 1 was the first part of the course. You are now going to do the final component of it. And I think in many cases, the most difficult component. If you get this right, you're going to do very well, inshallah. So the geometry, the trigonometry, look for the formulae, the tips, how to do it, shortcuts, like when you play the video games. If you don't get the cheat sheet or the tips and the tricks. Yeah, you have the tips and tricks. This is the man who's going to give you tips and tricks. Write it down, techniques. And once you have the formula, the techniques, you apply it. as Mr. Kota started yesterday, then he made a list of the things, the techniques that he used. So inshallah, today is your day. If you're going to waste your time, you could have been watching the rugby and the soccer and all that. If you're here, make sure your takeaway is valuable, because your time is valuable, and you're going to, we're starting next week to write. And I think you also, you're going to write. So take this into your paper and then see if your results are going to be better. Our grade 12, our other learners, detention is still well, but if you have to sit in detention, then your motivation isn't there. Do not be tempted to be distracted because you sit at the back. TLC and Darul Islam and the others, they were clever. They always take the front seats. Like the masjid, you go to Jannah first. Sit in the front row. Front row, you must go to. This is a VIP circle. We missed out. Inshallah, next time we're going to rush for the front seats. In class also, try to sit in front. You get more out of it. Inshallah. But yesterday you were fantastic. From morning to afternoon, you were interactive. You even picked up some mistake in the calculations. It happens. And then you picked it up. So that's brilliant. Alhamdulillah. Amen. I'm very impressed with these learners. I think I want to get them to come to Al-Azhar. Yeah. These are the cream of the crop here. Inshallah. But our learners, I'm very happy they all came. And they make me proud as a principal. Amen. But I'm only going to be proud if your parents are proud of your results. Do you agree with me? Amen. Amen. Inshallah. So this is your challenge, to show you are the top students of your school. Pure maths. And if you get it right, you're going to be proud of who you are and what you are. So if Allah make it easy for you. Amen. And bless this man that Amen. He keeps going. Amen. And Awqaf SA. Inshallah. All the best. May Allah bless you.
Shukran to you. How's a round of applause? Now, one thing we definitely, we enjoyed our time here yesterday. It was time well spent, and also it was a very good energy that we got from you. And I firmly believe, us in the team, we firmly believe that this is the cream of the crop that we do have over here, and you are the future generation. And mathematics and performing well is going to unlock that key to your future, because future careers are dependent on mathematics. We want you to succeed. We want you to be on the highest pinnacle and achieve your highest potential. We believe in you and we are behind you. That's enough speaking from my side. So for some of our online subscribers and cohort of learners that have joined, educators across South Africa, from Soshanguve, Eastern Cape, Northern Cape, Gauteng, KwaZulu-Natal, you're most welcome. Ahlan wa sahlan, Wamkile. And let us know in the comments from which province you are connecting to us from, as well as which school. Please vibe with us today, and Mr. Kota and Khalid. Give us your feedback. Let us have a two-way conversation as we navigate this conundrum that is maths. We'll be focusing on maths paper 2, and that's enough speaking from my side. Khalid will be taking you through the rest of the program as continuity presenter with Mohammed Kota. So Khalid, if you are ready, let's cue that launch sequence. We are all going to board the Awqaf SA maths rocket to call on Mr. Kota. Him and his ethanol, we've refueled this rocket, and we're all going to go on to another daraja, higher level. Khalid, cue the video.
We good, we good, we good. Welcome back, welcome back, welcome back. Day 2. Assalamu alaikum. Good morning and welcome to everybody. Welcome to South Africa. Jazakallah Hassanain, Mr. Mani from Al-Azhar Institute here in Cape Town, and to all our online learners. So yeah, a big ups to our math fam, right, from across the country. I see lots of learners coming in from different. Mango Fish is in the house. Mujahid, okay, Mujahid says he's from Dubai. We don't know which Dubai is he from. Abdul from Saudi. We've got Sonia. We've got Sumaya Daya. We've got, yeah, Zipo Zinkle. Well done, well done. Thank you all for tuning in, guys. I hope you guys are ready. Today is going to be a big day. I'm going to start finishing up on what we started yesterday, guys. We started the functions. I want to finish the functions, do the finance, and we'll go straight into math paper 2. So I hope you got your scientific calculators. I hope you've got your hydration and your stationery and your exam pads, writing material. Guys, let's get cracking. Let's get started. Here we go. Now, yesterday we ended up, remember, just to give you a recap, we did the whole of algebra yesterday. We also did the straight line. We did the parabola. We did the hyperbola. We did the hyperbola with a shift. We're now doing the exponential. And then what I'm going to do, I'm going to throw you into the deep end. I've got some questions here from the past papers to make sure that you are familiar. The main purpose of yesterday and today is to get you familiar with the structure of the paper so that you can already anticipate what's about to come in your final exams. Right? Remember, you need to be familiar. So when you open up your paper, everything needs to look familiar to you. If the problem comes in when everything looks Japanese, and then you don't know where to start, you start panicking, you start stressing, and even the easy stuff you start getting wrong. So here we go, guys. Let's start with the exponential. Put the heading there, exponential graph. We're going to be doing the exponential and the exponential with a shift. The standard formula is y equals a to the power x, or you can say f of x or h of x is equal to a to the power x. So whenever you see x in the power, it is exponential. Very popular one. Let's start off with sketching. Remember, if you weren't part here yesterday, if you weren't part of the program yesterday, we were doing sketching and finding equations. Sketching and finding equations. So that's exactly where we're going to continue today. If I asked you to sketch the graph, f of x is equal to, this is a very popular one, 2 to the power x. They ask you this grade 10, 11, and 12, right? And they give you a graph, let's say f of x is equal to a half to the power x. Okay, so I want you to look at these two. This one is a positive exponential. This one is a negative exponential. So in order to sketch the graph, what we're going to do, I'm going to draw a table. Now remember, for the hyperbola, I told you to use plus or minus 3 factors yesterday. Here we're not going to use factors. Here we're just going to say 0, 1, 2, minus 1, minus 2. Right? These values will always stay the same on your x. Now we substitute it back into the original in order to get our y. So here goes. We put 0, 1, 2, minus 1, minus 2 in order, just like that. Now we substitute 2 to the power 0, 1. 2 to the power 1, 2. 2 squared, 4. 2 to the power minus 1 is a half. By now you should know 2 to the negative 1 is a half. 2 to the minus 2 is 1 over 2 squared, which is 1 over 4. Here we go. Sketch your graph. Let's plot our points. Y-axis, x-axis. And let's go. 0 and 1. 0 on my x, 1 on my y. That point will always be 0 and 1. Then we got 1 and 2. 1 on my x, 1, 2 on my y. 2 on my x, 4 on my y. Minus 1 on my x, half on my y. Minus 2 on my x, a quarter on my y. Join the dots and make sure that it does not touch your x-axis. Your x-axis is called what? Asymptote. Right. Your x-axis is your asymptote. And what is the equation of your x-axis? Y equals 0. Important things to remember in your graph. Onliners, let's see how we're doing there. Shoshanguve is reporting for 2 days. Welcome. Let's go. I know, easy stuff. You'll see it when we do the application. Remember, this is your basics. You need to cover your basics. You need to master these basics. If you can't do this, you won't be able to do functions. You'll see it when I do the application into past papers just now. Remember, we're still focusing on what, guys? We're focusing on processes and procedures. Right, let's go on to the negative graph on this side. Why is it a negative graph? So that's your question. You need to sketch it. So in your answer, the first thing you do, you say y equals a half is 2 to the minus 1 to the power x. So y equals 2 to the power minus x. There we go. That's why it's a negative graph. So a positive graph goes in this direction, and a positive graph is called an increasing function. Take all these notes down. Very important. Remember, I'm going to summarize everything that you need to know about these functions in today's session. Now so this here is a negative graph. Now we draw our table. We draw it exactly the same as we've done the previous one. There you go. Here we go. We put x, y. We put 0 in the middle. We put 0 in the middle. We put 1, 2, minus 1, minus 2. Now we substitute it back into the original. So 2 to the negative 0 is 2 to the 0, which is 1. 2 to the minus 1 is a half. 2 to the minus 2 is a quarter. 2 to the minus 1 is 2 to the plus 1, which is 2. 2 to the minus 2 is 2 to the plus 2, which is 4. Now we go to our graph. There's our graph. Let's plot our points, guys. These are our coordinates, 0 and 1. There we go, 0 and 1. It will always be 0 and 1 for standard exponential. Why? Any base to the power 0 is always 1. In exponents, whenever your power is 0, the function value, any base to the power 0, will always be 1. So your y value will always be 1. Now, minus 1 and 2, negative 1 on my x, 1, 2 on my y, minus 2 on my x, 4 on my y, 1 on my x, half on my y, 2 on my x, quarter on my y, and we join these dots, making sure it doesn't touch our x-axis. Again, our x-axis is our asymptote. Equation, y equals 0. So there we go, and this is called a decreasing. If a positive is called an increasing function, a negative graph going in this direction is called a decreasing function. Okay, now that we've got this, and now that you've taken it down, let's compare the two and let's see what is the same about the two. So let's summarize everything about this, because once you know this summary, this will help you to get 100% for this topic. Onliners, how are we doing there? How's our online fam doing? Are you guys lit? Right. Let's go. You've got this down, right? So here's the positive, here's the negative. I'm just going to show you something here quickly. Let's just draw quickly a rough sketch. So there we go. This is the positive. 0 and 1. And here's the negative graph. 0 and 1. Okay. X-axis, y-axis. Right. Let's look at the summary of these two graphs. So let's write this down. All standard exponential standard. We talk about standard graph. Y equal a to the x. Exponential graphs. When I say all, I mean positive or negative. What can we say about these two? Have a look at them. What can we always identify will always be the same between a positive and a negative? They only have one y-intercept, yes or no? So write this down, only have one y-intercept. And what is that? 0 and 1. Number 2, the x-axis is your asymptote for both graphs. And what is the equation of your x-asymptote? Y equals 0. The equation of your y-axis is x equals 0. Right. What's the domain of both graphs? The x values. Any x value will give you a y value. Any x value will give you a y value. So you just say x is an element of real numbers. Or you can say from negative infinity to positive infinity. Whichever one. You don't need to give both. What is the range for both the graphs? The y value. Remember, domain refers to x. Range refers to y. Okay. So it's all your positive y values. All your positive. So you'll say y greater than 0. Y is an element of real numbers. There we go. And now we're going to be doing... No, we're finishing up paper 1. And then we're going to go into paper 2. So remember this. I want you to learn this. I want you to memorize this. Because we're going to be applying this a lot. Now we do reflections. Very important. Your reflections of graphs. So I'm just going to erase this. I hope you've taken this down just to show you quickly. I'll come back to this. Those of you who still I'll give you a couple of seconds to finish up this. You've taken it down. You've understood it. Step number 1, let's draw your steps in. Step number 1, draw your table and put in your x values. Step number 2, you substitute your x values into your original. Step number 3, you sketch the graph. So it's only done in 3 parts. It's only done in 3 parts. The same thing here. Here's step number 1 for when this is a fraction. You want to get it. You want to remove the brackets. Step number 2, put in your x values. Step number 3, substitute. Step number 4. So here for a negative graph, you've got 1 extra step. Okay, so that's your exponential graph in a nutshell. Let's go to the next page again. Those of you who are taking it down, you can complete this. Now let's do reflection. So let's say this graph was y equals, okay, so we said this was y equal 2 to the x, y equal half to the x, right? But let's take the graph y equal 2 to the power x. Let's do reflections. Remember, learn these reflections. And they apply to all graphs. So this is not exclusive only to the exponential graph. So these laws of reflections apply to all functions. So you get the reflection about the x-axis. You get a reflection about the y-axis. And you get the reflection about the line y equal x. What are the rules? When you reflect something about the x-axis, the y sign changes. When you reflect something about the y-axis, the x sign changes. When you reflect something about the line y equal x, the two swap over. X becomes Y, Y becomes X, so the two swap over, and the signs don't change. Right, so if we had to reflect this original one about the x-axis, what would your final answer be? If we had to reflect this about the x-axis, the y sign changes, so you'll have minus y is equal to 2 to the power x. In your final answer, can y ever be negative? No, so we divide by negative, here's your final answer. They might tell you to put it in the form h of minus 1x. Your new graph, they want it like that, or they can ask you for p of x or anything else. So if you want to, you can say now h of minus 1x, the reflection, divide by negative, minus 2 to the power x. Reflected about the y-axis, the x sign must change. So h of minus 1x will equal to, the x sign must change, 2 to the power minus x. So these two are reflections of each other about the y-axis. And then about the line y equal x. So now, instead of y equal 2 to the x, you'll say x equal 2 to the y. And you can leave it like that for now. In grade 12, we'll use logs. But don't worry about it for grade 12. For now, this is all you need to know. Are we all okay? Thumbs up? We're good. We're ready. Now let's do, to find the equation of this is very easy. So take this down. What have we quickly summarized? What have we summarized? That all standard exponential graphs have only one y-intercept, 0 and 1. Your x-axis is your asymptote. The equation of your x-axis is what? Y equals 0. Good. Positive graph is an increasing function. A negative graph is a decreasing function. The domain for both graphs, x is an element of real numbers or negative infinity to positive infinity. The range of both the graphs, y greater than 0, y is an element of real numbers. Reflect. This is how you're going to test yourself before the exam to see whether you know your theory. Then you're going to tell yourself, right, do I know the rules of reflection? Reflection, if I reflect something about the x-axis, y sign changes. If I reflect something about the y-axis, x sign changes. And if I reflect something about the line y equal x, x becomes y, y becomes x. The two swap over. There we go. So now you know the summary of these two graphs. So what I'm going to do now, onliners, hope you're paying attention there. Here we go. I'm clearing the frame. Now they'll give you a graph, as you'll see just now when I start doing application. This is the last part, guys, and then I'll show you how to shift the graph. So let's say they gave you a graph like this in the exam. Right. They call this point P, X and Y. And they give you another point here, any point on the graph, R. And let's say they tell you this point is 4 and 8. Now they say the following graph H. They tell you H of X is equal to A to the power X. So they're telling you it's a standard exponential. Learn to read your formula. Obviously, you need to find the value of A. So question number 1, find the equation or find the value of small a. So all we're going to do, we're going to go y equals A to the power X. So we know that's X, that's Y. So we're going to say 8 is equal to A to the power 4. We're using R's coordinates, 4 and 8, for X and Y. So now 8 to the power 4 is equal to 8. A is equal to, if this was square, we'd find the square root to get rid of the square. If it was cubed, we find the cube root. So it's to the power 4. So what root will I use? The fourth root. The fourth root of 8. That's it. And now, so if you want your final equation, h of x will equal to the fourth root of 8, that's a, to the power x. And there we go. Game over. Problem solved. You got your first 3 marks. The second question they can ask you, they want the coordinates of P. I'm just showing you how we use a summary to answer our questions. The coordinates of P. Guys, tell me what's the coordinates of P? Without thinking, it's a no-brainer. 0 and 1. There we go. That's your next 2 marks. Question number 3. They want the equation of the asymptote. What's the equation of the asymptote of H? Equation of asymptote, y is equal to 0. Question number 4. What's the domain of the graph? X is an element of real numbers. Question number 5. What's the range of the graph? Y greater than 0. Y is an element of real number. Can you see how we're using that summary to answer all these questions? Now they say, question number 6, they want the equation of g of x if g of x is h of x reflected about the x-axis. So that means when it's reflected about the x-axis, what happens? The y sign changes. So that means now, remember, minus g of x, the y sign will change, will equal to the 4th root of 8 to the power x. But in my final answer, g can't be negative. So I'm just going to write it here on the top. So we're going to say g of x will equal to minus the 4th root of 8 to the power x. That's the answer for the last one. And there we go. You're going to get 10 marks. That's 10 marks in the exams. Easy. Brilliant. Now you know the exponential. You know the exponential. If they had to shift the graph, no problem. We do it the same way as we did the hyperbola yesterday. So, watch here. Take this down. Let's put mark allocation. So you might say, okay, sir, how many marks will I get for each of this? So you'll get 3 marks there. You'll get 2 marks there. You'll get 1 mark there. 1 mark, 1 mark. The equation of g of x, another 2 marks. So let's see how many marks is this in total. 2, 3, 4, 5, and 5. Total marks, 10. Agreed? We all good? It's not difficult. The reason why you find it difficult is because you don't know the processes. And you've got so many stacks of notes. So now what you do, guys, whatever other notes you have about this, you don't worry about. Leave it. Don't study from your textbook. You study from the notes that we've done today. Because this summarizes everything. There can't be anything that they can ask you now that can kill you. Now you can work through past papers. Now watch here. So now if I told you, h of x is equal to 2 to the power x plus 3. So now this here is an exponential with a shift. Yes or no? So this is given in the form h of x is equal to a to the power x plus q. Q is my asymptote, my y asymptote. Whatever. So here you know your y asymptote is at 3. So watch here. So all you're going to do now, there we go. There's your graph. You know. Now look here. So we're going to go to 3. The graph is going to shift 3 units up. Right? So that means we're going to go 1, 2, 3. That's my y asymptote now. So now you put a dotted line through 3. So your whole x-axis has shifted 3 units up. Right. Your original graph went through 0 and 1. That was your original graph without the 3. If we block out the 3, your original graph went through 0 and 1. We're going 3 units up. So basically the graph is now going to go like that. What do you think that one's coordinates is going to be? 1 plus 3 is how much? 0 and 4. What's the equation of your asymptote? Y equals 3. Remember, your asymptote's always going to be 1 unit. For positive or negative, it's going to be 1 unit below your intercept. So if your intercept is at 4, your asymptote is going to be at 3. Or if your asymptote is at 3, the intercept is going to be 1 unit above. Are you all with me? But now what happens if they say that this graph is a reflection? Draw a new graph that is a reflection about h, about the line y equal minus 3. Right. So that means if you needed to draw another graph as a reflection of this, about this line, that graph is going to go like that. What do you think that is going to look like? What do you think the equation of this graph is going to look like? It's a reflection. This would have been your x-axis, so your y would have become 0. So this means the equation of this graph would be h of minus 1x is equal to minus 2 to the power x plus 3. Plus 3, because your asymptote is still staying at 3. It's not coming down to minus 3. Remember, this negative actually came on this side because it was a reflection about the x-axis. So my y sign changes. Now we divide by negative. We divide by negative. So h of minus 1x is equal to minus 2 to the power x plus 3. And what do you think this one's coordinates is going to be? 0 and 1 unit below. 2. Very important. It's very important that you're able to analyze these graphs. This is called graph analysis. Okay. Right. So now let's go. Now let's go. I'm now going to give you a hyperbola with a shift and a straight line. Do you know how many marks is this, guys? This block of questions. 20 marks. Here we go. Here's a 20-mark exam scenario. Grade 10s, are we ready? Lovely. Let's go. Onliners, how are we doing? Right. You guys ready? I'm clearing this. Please remember what I just showed you now. But let's first start with a hyperbola. So they tell you f of x, you can take this down, f of x is equal to 3 over x plus 1. And they tell you g of x is equal to minus 2x minus 4. Now, before we even begin, let's analyze which two graphs are they giving us. They're giving us a hyperbola with a shift, not exponential. X is not in our power. And they're giving me a straight line graph. So here goes. The first question. Sketch both the graphs on the same set of axes for 4 marks. Show all calculations. Sketch both graphs for 4 marks. Question number 2. Write down the equation of the asymptote of f. They want the equation of the asymptote of f. Question number 3. The domain of f. Question number 4. Solve for x if f of x is equal to g of x. Right. Question number 5. Find the y-intercept of k of x. Now, k of x is a brand new graph. If k of x is equal to 2 of g of x. And write down the coordinates of the x and y intercepts of h if h is the graph of g reflected about the y-axis. Okay, so now I want the x and y-intercepts of h if h of x is g of x reflected about the y-axis. There we go. Here's an exam model for you. After this, let's see. I'll give you a parabola, and then I'll give you an exponential. These we're now straight into final exams. Okay, so go for it. Have a blast. Have a blast. Take them all down. So that's 4 marks, 2 marks, 2 marks, 4 marks, 3 marks, and 2 marks. 4, 8, 10, 14, and 5, 19 marks in total. Onliners, you're nice and fresh this morning. Sunday morning doing math. Kicking it live with math. Come, guys. Let's see how good are you guys. Get the full 19 marks. Get the full 19 marks here, guys. F of x is 3 over x plus 1. On the same set of axes. So f of x is equal to 3 over x plus 1. Normally, this is your hyperbola. Your standard hyperbola. Now you know your hyperbola is going to go down. It's going to go in this direction. A standard hyperbola, if you just had that, and because this is positive, you know your hyperbola is going to be in this direction, and it's going to be in that direction. That's what your standard graph is going to look like. But the graph is shifting 1 unit up. So we're going to go up to 1. The graph is moving 1 unit up. So your graph is going to come in that direction. There we go. And this direction. And it's going to cut on my x-axis. So we know my y value here is 0. So we need to find out what is this x value, because now this cuts on my y-axis, or on my x-axis. So you say let y equal to 0. Let y equal to 0. So you're going to get 3 over x plus 1 is equal to 0. 3 over x is equal to minus 1 over 1. Cross multiply. Minus x will equal to 3. X is equal to minus 3. That means that point has got to be negative 3. You have to show this point on the graph. This is graph F. And this is y equal 1. That point there is 0 and 1. Your asymptote. There we go. There's your first graph sketched. Now, what's your second graph that they asked you? Sketch both the graphs. The other one's a straight line. Now, I showed you yesterday how to do it. G of x is equal to minus 2x minus 4. Let x equal to 0. Let x equal to 0. Y equals negative 4. Let y equal to 0. We did this yesterday. Minus 2x minus 4 equal to 0. Now solve for x. Minus 2x is equal to 4. X is equal to 4 over negative 2. X is equal to minus 2. So here we go. That's minus 2. And we go 1. What's our y value here? Ooh, minus 4. 1, minus 1, minus 2, minus 3, negative 4 is there. Now we join the dots. Let's draw it in red. And there we go. There's our two graphs. Graph F and graph G. Are we all okay? Onliners, are we all right? Did you get it right? Did you get it right? So there we go. You're going to get full marks for this. What's the next question? So we sketched both graphs. The equation of the asymptote of f. The asymptote of f. So let's go to the asymptote of f. We're looking at graph f. Here's the equation of our asymptote. So the answer to question number 2 is y equals 1. The answer to question number 3. Let's go to let's go back. So we're done with that. We're done with that. The domain of f. F's domain. X is an element of real numbers. X is an element of real numbers, but x is not equal to. Which value will this graph never touch? 0. So x is an element of real numbers, but x is not equal to 0. You must put x not equal to 0. You can't leave it as x is an element of real numbers, because then you're telling the person that 0 is included, which is wrong. It's incorrect. Number 4. Question number 4. Solve for x if f of x is equal to g of x. Now, clearly, we can see from these two, they don't touch each other. These two graphs never intersect each other. I don't think there's a value for x. I don't know, but let's do it algebraically. And let's see whether there's a point. I don't think the two, there's no values, because these two graphs won't touch. But anyway, let's check. Let's do it algebraically. Let's show that the two graphs will never touch. So we got g of x is equal to minus 2x minus 4. So that means 3 over x plus 1, f of x, is equal to g of x. Now let's solve for x. Now, basically, they're just testing your knowledge of equations. I don't think it's going to work, because we can clearly see these graphs will never touch each other. Let's work it out and let's see. I think we're going to get a square root of a negative number. That means there'll be no real values of x. That's what I assume. But in any case, let's go. We're going to get rid of this x. We're going to multiply that by x. We're going to multiply that by x, multiply that by x, multiply that by x. So we're out of that. So let's go. Normal algebra now. That's 3 plus 1 times x is equal to minus 2x squared minus 4x. Let's take this on the other side. 2x squared plus 4x plus x plus 3 is equal to 0. 2x squared plus 5x plus 3 is equal to 0. There, you can clearly see here, guys, if you factorize this, you're not going to get factors of 2 and factors of 3 that are positive, that will give you a positive here in the middle. So you'll say, therefore, no values of x. No values of x. These two graphs will never touch. This here will continue that way to infinity, that way to infinity. This will come down to infinity, that way, that way, that way. These two graphs will never intersect at any x value. So there's no solution. Okay. Now remember yesterday, I showed you that about the parabola. So let's do one with a parabola, and then I'm going to give you a hyperbola and an exponential with a shift. Okay, here we go. Look at this. So let's see whether you remembered yesterday. We're coming towards the end of functions, guys. I'm just showing you now how we apply what we've learned to exam scenarios. Right, let's go, let's go, let's go, let's go, let's go. Right, you've all taken this down. You will answer this because it was for 4 marks. If they said use the graphs, you'll just say no values of x because you can clearly see they don't meet. If it was only for 1 mark. But it was for 4 marks and they said show all calculations. So you had to show all of this to show that they have no solutions. Okay? Right. So here's a graph. Take this one down from a past paper. Take this one down. We're going to do this set of questions, and then we're going to do a set of questions with a hyperbola and exponential. Right, they give you -5 and 32. They give you this point here as -5 and 32. They give me this point here as 3. That is 0. This is graph F. Now, they give you another graph coming that way there. And this is graph G. They tell you that f of x is equal to ax squared plus q. They tell you g of x is equal to mx plus c. Question number 1. I want the equation of f, or I want a and q. Find a and q. Find the values of a and q. Question number 2. Find the values of m and c. Question number 3. For which value or values of x is f of x greater than g of x? Where is f of x less than or equal to g of x? Where is f of x equal to g of x? Okay, so let's just call this for explanation purposes point A, point B, point D. They can even ask you what's the length of OA. OA is 3 units. They can say find the length of AB, the distance between the 2 x-intercepts. They can ask you for OD, from 0 to your turning point. Right, now the first, how many marks? 5 marks. 3 marks. 2 marks, 2 marks, 2 marks. 5 and 3, 8, 10, 12, 14. Total marks, 14. This will test whether you paid attention yesterday. It's all yesterday's work. I showed you the processes yesterday. Here's 14 marks for you. Okay. Let's do it. I'll help you along the way because we don't have much time. We're going to finish this one up. Like I said, I promised you the next one is going to be a hyperbola with a shift and an exponential with a shift. Those 2 graphs combined on one graph. They'll always give you, in most cases, two graphs. Sometimes they'll help you and they'll only give you one isolated graph. No problem. Onliners, how are we doing there, guys? I missed the last two questions. What were the last two questions of that? Oh, I did. Find the y-intercept. So where were we? Oh, when I erased all that. Find the, okay, no problem. Thank you for that. Guys are paying attention. So that was f of x equal to g of x. Let's go here. Find the y-intercept of k of x. So let's answer question number 5. K of x is 2 of g of x. So k of x is equal to 2 times g of x. What's g of x? Minus 2x minus 4. Yes or no? Yes or no? Right, so we just multiply. That will give me minus 4x minus 8. That's k of x. And what do they want? The y-intercept. So let x equal 0. So y is equal to negative 8. So the y-intercept is 0 and minus 8. That's the answer for question number 5. That's how you will answer it in the exam. Because they told you, k of x is 2 of g of x. So it's 2 times g of x. There's it. 2 times g of x. But be careful. I just want to alert you to something. Be careful. Here it's 2 times g of x. What if they told you k of x is equal to g of x minus 1? Listen, they can twist the question. What if they told you that k of x is g of x minus 1? Find the y-intercept. Totally different, guys. Let's just do this one. I just want to show you this one here. Remember, this is 2 times g of x. This is 2 times g of x. Let's do this next one here, just to show you how it's done. What was this one? 3 over x plus 1. Eh? Right, so let's go. Let's erase that. Watch here. Watch here. Guys, pay attention. So now they tell you k of x is g of x minus 1. So k of x is equal to g of x minus 1. So k of x is equal to, that means for every x, I need to put x minus 1. So it's minus 2 into. For every x, remember your normal graph was g of x. So instead of x, what are you now going to put in for every x? But now you're not saying x, now you're saying x minus 1. You're replacing every x with x minus 1, minus 4. This is equal to minus 2x plus 2 minus 4, which is equal to minus 2x. 2 minus 4 is minus 2. Now you're going to say let x equal to 0. Therefore, your y-intercept of this graph would be 0 and minus 2. There's it. Let x equal to 0. Therefore, y is equal to minus 2. The y-intercept would be 0 and minus 2. Be careful. There's a difference between g of x minus 1 and 2 of g of x. When it's g of x minus 1, it means that for every x, you pull it out and you put x minus 1. If they say 2 times g of x, that means you say 2 and then in brackets, whatever g of x's equation is, you put it in brackets. Know the difference. Know the difference from now till grade 12. Okay? Now, find the x and y intercepts if h is g of x reflected about the y-axis. So, g of x reflected about the y-axis, what happens? So, here's g of x. g of x is equal to minus 2x minus 4 is reflected about the y-axis, so x sign changes. So that means h of x is equal to the x sign changes, 2x minus 4. Now they want the x and y intercepts. How do you find x and y intercepts? Let x equal to 0 solve for y. Let y equal to 0 solve for x. There we go. There's your answers. Right, now to get your intercepts, you're now going to say let x equal 0. Let x equal 0. Y is equal to minus 4. Now you're going to say let y equal to 0. So now 2x minus 4 is equal to 0. Here comes our answer. We need to solve for x. Right, so 2x is equal to 4. X is equal to 4 over 2 is 2. Now remember, they want the coordinates of your x. They want your x and y intercepts. So x is 0. Y is minus 4. X is 2. Y is 0. There we go. That's your answer. That's your answer. This is how you will answer that entire last question. There we go. Agreed? Full marks. Full marks. Are you guys feeling a little bit more confident about functions now? How to sketch a straight line, how to determine the equation. How to sketch a parabola, how to find the equation. Like here. Right, let's see. Who remembers yesterday's work? Now we know. Let's put down what we know, guys. We know if this is 3, then what must b's coordinates be? Negative 3. Now remember the formula I showed you yesterday. A into x minus x1 into x minus x2. That's exactly this question here from a past paper. So try it. Go for it. Go for it, guys. 8, 10, 12. 14 marks here, guys. 14 marks. Onliners. Right. Mango Fish says it has to intersect. Where does it intersect? Where do they intersect? We had 3 over x. I'll go through it. I hear you. Are there solutions for that? Let's check. Now remember, you are in grade 10, so you don't get to use the quadratic formula. Yes, you don't get to use the quadratic formula in grade 10. So what did we had? We had 2x squared plus 5x plus 3. 2x squared plus 5x plus 3. Let's just go here. Who's got a silver calculator here, the factorizing calculator? The Casio FX? No? You got the blue ones? Silver one? No? Okay, never mind. Let's open up my FX. Carry on with this, guys. Carry on with this one. So mode ax squared. So we say 2. And then we had 5. And then we had 3. Equal. Minus 1.5 and minus 1. Minus 1,5 and minus 1. But you won't be able, if you had to factorize it like this. Okay, so you guys are still busy here. I'm doing that previous question. 2x squared plus 5x plus 3. If we had to factorize this, factors of 2, factors of 3, let me just do it here on the side. The factors of 2, the factors of 5, the factors of 2, the factors of, no, factors of 3. That when cross multiplied will give me a 5. 2, 1, 3, 1. It works. Hey, guys, it actually works. So 2 times 1 is 2. 1 times 3 is 3. Plus a positive type. Whoa, it actually works. 2, 3, 1, 1. Guys, in that one there, just to go back, it actually works. So if we factorize that, it will give you 2, 3, 1, 1. 2, 3, 1, 1x and 1 plus x is equal to minus 3 over 2, or x is equal to minus 1. There we go. Yes, you're right, Mango Fish. It actually does factorize. Well done. Yeah, I forgot my own method. I'm just seeing, we had the graph there at minus 1.5 on my x and 1 on my y. Those two were equal. Okay. Solve for x. So here are your two x values in the Snotkop method. If we used where the two graphs were equal in that previous question, we actually get x is equal to minus 3 over 2 or x is equal to negative 1. Thanks, guys. Right, let's go back here. Okay. So what do we have? We got negative 5 and 32. We got a point on the graph, minus 5 and 32. We got x1 equal to negative 3. We got x2 equal to positive 3. So y equals a into x minus x1 into x minus x2. So y is 32, right? Because it lies on the graph, guys. It lies on the graph. That's your y, that's your x. So 32 is equal to a into x is minus 5 minus 3 plus 3 into minus 5 minus 3. Which alphabet are we looking for, guys? A. So 32 is equal to a into. That would give me minus 2. That would give me minus 8. 32 is equal to 8 times 2 is 16a. Divide by 16, divide by 16. A is equal to 32 over 16 is how much? 2. So y equals 2 into x plus 3 into x minus 3. Y equals 2 into x squared minus 9. Y equals 2x squared minus 38. So that means your A is equal to 2. And what did they ask you for? A and Q. So basically 2, there we go, 2 and minus 38. Q is equal to negative 38. 2 and negative 38, guys. So we're going to go back to our original. Change that from your original. 2 and minus 38. 2 and minus 38. So minus 38 is here at the bottom, the y-intercept. So it's the same y-intercept for my straight line, minus 38. Because they meet at the same point. So that's what you do, guys. The minute you get your answer, go back to your original equation. Yeah? Negative astaghfirullah. Yo. Minus. Here, it's Sunday. Positive 3 times negative 3 is negative 9. Okay, so that gives me 2x squared minus 18. So now that becomes minus 18. Thank you. La hawla wa la quwwata astaghfirullah. So that becomes 18. And that is 18. And that is also 18. Brilliant. See, I told you, when you start picking up my mistakes, now you know you're sharp. Right. Now answer the next question. Find M and C. So let's just go back here. There we go. Those of you who are taking it down. Okay. So we got 2x squared minus 18. My next question is to find M and C. I showed you guys a shortcut yesterday. I showed you the shortcut yesterday to find the gradient here of this chain. So now we're going to go. Remember, y equals mx plus c, mx minus 18. What am I short of? My m value. What did I show you yesterday? What's the shortcut? No, change the sign of y over keep the sign of x. Remember, change the sign of y over keep the sign of x. 18 over 3 is how much? 6. So therefore, m is equal to 6. So find m and c. There we go. Here's m, there's c. So m is equal to 6. C is equal to negative 18. What was A and Q? A was equal to 2 for the first one. A was equal to 2. Q was equal to negative 18. Now go back again. Change that to 6. There we go. You always go back and fill in your information on your functions. Now, greater than, less than or equal to. Greater than means above. Where is the one above your other? Less than or equal to means below. Equal to means where do they intersect or where do the two graphs touch? For which values of x? So let's go. Let's answer. Let's call us 3.1, 3.2, 3.3. Right. Let's call this 3.1, 3.2, 3.3. So the answer for 3.1. Where is f of x above g of x? F is above g for all these values, and f is above g for all those values. So that means for all your x values greater to the right, x greater than 3, or all your x values to the left of 0. That's your answer for the first question. For which values of x? Right, onliners? Yeah, I was too excited for the class. And you got a sharp cohort of learners. Well done. Well done. Okay, 3.2. Where is f of x less than or equal to? So below. Where is your parabola below your straight line? Your parabola is underneath your straight line. Where? For all these values of x. There where I'm shading it in. So it's between 0 and 3. So your answer is x less than or equal to 3, but greater than or equal to 0. Because there's an equal to, we use the equal to. And it's between these 2 points. Between 0 and between 3. Are you all following? And where do they intersect? Let's answer the last question. Let's answer the last question. Now, the reason I'm spending so much of time on functions, because functions is a lot of marks in your paper. About 30 marks. Now, imagine if it's about 30 marks on functions, 30 marks on algebra, you already got 60. You already got 60 marks. Right. Where is f of x equal to g of x? F of x is equal to g at x equals 0. That's the one point where they meet. Do not go and say minus 18. They're not saying for which values of y. They're saying for which values of x. At x equals 0 and at x equal 3. There we go. We are done. And you got full marks there. Now, let's wrap up. Let's wrap up the whole of the functions component. And that will take us to our first break. It's 10 past 10 already. In the last 20 minutes, it will take us to our first breakfast break. You come back. I'm going to go into paper 2. We'll end up with finance. Right? But I want to get into paper 2 immediately after break. And I want to get into analytics. It's another 20 marks, easy marks. Then we get into trigs, another 30 to 40 marks. You need to know your trigonometry. Right? Okay, let's go. We're going to try and do as much as we can until 3 o'clock. As much as time permits. I'm clearing here. And I hope yesterday and today has given you a brand new perspective about mathematics. Very different to what you see in class, very different to the way you interact with math. And I hope as from tomorrow, when you get back to school, you start interacting with math and start interacting with your teachers at school on a different level. You start vibing on a different level. Yes. To where? Which one? The one where we equated the two. This. Oh, the answer for number 1, did we erase that? No, here's it. Okay, somebody just asked for the memo for, this was the answer to question number 1. Are we good? Let me know when I can clear the frame. We good? Lovely. Okay, so let's clear the frame. We done there. Let's clear that frame. Let's go back. We finished up there. We got full marks, total marks there. We got total marks there. And yes, we know our expert. So here goes. Let's see how sharp are you guys now. So here we go. Take this one down, guys. This is the last block of questions we're going to be doing before our first break. Right. They give you a graph -2 and 3. So that it goes through -2 and it goes through 3. Take this graph down, guys. So the graph goes like that. And then it's got an asymptote. And then this graph continues down that way. And then we got another graph here. We got a graph there. And we've got another graph coming down this way through 3. Right, this is graph G. This is graph F. That's your y-axis. That's your x-axis. Let's see what questions. Any other information they give us on there? Nothing else. So they tell us that f of x is equal to k over x, which is the same as saying a over x plus q. And g of x is equal to a times b to the power x plus q. Now, just by looking at that, we already know hyperbola with a shift, exponential with a shift. Important to pick up these crucial, critical aspects. F and G have the same horizontal asymptote of y equal -4. So both graphs have a same horizontal asymptote. This is what's given to you of y equals -4. So the first thing we do, we go there and we put -4. That's our line y equal -4, and that is our asymptote. It's given to us. Okay, here we go. Questions. Find the values of Q, K, A, and B. Question number 1. Find the values of Q, K, A, and B for 7 marks. Question number 2. For which values of x is f of x minus g of x less than 0? Question number 3. They want the range of f. Okay. Let's see. Go for that. So that's 7 marks. That's 2 marks. That's 2 marks. Total marks 11. After answering these questions, this brings us to the end of the first session. It will take us to breakfast. Right. What is Q? Let's have a look at this. Onliners, how are we doing there? Inshallah, if we have enough time today, we'll do our Euclidean, but I'm going to try and push for Euclidean. But remember, we still got analytics, we still got finance, we still got the whole of trigonometry, and we got trig graphs. Don't forget trig graphs. Inshallah, if we have enough time, even if you've got 30 minutes left or 45 minutes left, we'll push for Euclidean as well. Okay, remember there's another workshop, guys. There's another workshop also coming up at the end of the year. And then it's no longer processes. Then it's straight. I'll be sitting here with a whole stack of past papers. And all we'll do is be one big group session. And at the end of that, you should be fully prepared to write your final exams, inshallah, Ameen. Right, let's go. Let's find Q. What's Q? What does Q mean? What is Q? Asymptote. So we already got Q. So the first, I'm just going to, because we need some space here. So I'm going to write here Q. Q is equal to -4, your asymptote. Right. How do I find K? So we got Q. How do I find K? So we got y equals k over x plus q minus 4. On which graph does it lie? On graph F. Yes or no? And what, is there a point given to us on graph F? Yes. What is that point? 3 and 0, not 0 and 3. So that's x, that's y. So y is 0 is equal to k over, what's x? 3 minus 4. Now here we go. Equations again. Equations again. Your algebra. So take the 4 on the other side. 4 equals k over 3. Remember, minus 4 will go on that side as plus 4. So k is equal to times 3 times 3. K is equal to how much? 12. So q is equal to -4. K is equal to 12. So let's go back here. K is equal to 12. I said, go back and change it. When you know you right, go back and change it in your equations. Right. And we've got -4 here already. Right. So let's go. Now find A and B. -4. Now we need to find A and B. Interesting. Interesting. What do you think is going to happen? Yeah, I'm given 2 points on the graph, and we got 2 unknowns. 2 unknowns, 2 points. Ah, beautiful. Simultaneous equations. I think that's where we're heading with this. Again, I'm not working from a memo. You giving me the answers. We're all working through it together. But obviously, we don't need a memo. If we know we right, do we need a memo? If they ask you a question like 2 plus 2 is 4, do you need a memo to check whether 2 plus 2 is 4? No. So if you know your processes are right, and I've got 10,000 that will correct me now if I make a mistake in my algebra, like they wonderfully do. Right. Let's go. Let's answer. Let's find A and B now. Let's find A and let's find B. So we got Q is equal to -4. We got that. We now want to find A and we want to find B. So A is there, B is there. I got 2 points here, guys. I got 3 and 0. And what is this point? 0 and -2, right? So let's go. So I got y equals a, b, x, a times b to the x minus 4. Let's use the first point, 0 and -2. X and y. Let me just double check. 0 is my x, -2 is my y. 3 is my x, 0 is my y. It's always important to double check so you don't make any mistakes. Remember, incorrect substitution is going to mean a wrong answer. So let's go. Y -2 is equal to, we don't have A, we don't have B, we got X is 0, -4. So -2 is equal to A times B to the 0. Any base to the power 0 is how much? 1. -4. There we go. So now again, we're solving for A. So -2 plus 4, 2 is equal to A. So there we go. We got A is equal to 2. Now we use the other point. Y equals ABX -4. I've got A is 2. Y equals 2B to the X -4. Right. We now use the other point, 3 and 0. Let's use the other point, 3 and 0 now. Now I'm going to use the point 3 and 0. Algebra and proper correct substitution. 0 equals 2, B, X is 3, -4. So I'm just moving over here to the side, guys. I'm moving over to the side. So 2B cubed is equal to 4. B cubed is equal to 4 over 2 is 2. B is equal to the cube root of 2. So what is A? A is 2. What is A? A is 2. So we go 2 times B is the cube root of 2. So I need a little bit of space there. Let's go back. 2 times the cube root of 2 to the power x. -4. There we go. That's your answer. 2 times the cube root of 2 to the power x -4. Where is f of x less than f of x minus g of x less than 0? Where is q is equal to -4? Well done, Nabila. Lemokhang, k is equal to 12. Beautiful. Last 2 questions. Hey, we're moving on fantastic time. We got 6 minutes left before breakfast. Let's go. Now, how do you do this? Now, you just got to use your brains a little, not too much. Watch this. We're answering question number 2. We're answering question. Now, all this calculations was all for question number 1 for 7 marks. Question number 2. F of x minus g of x less than 0. Do me a favor. Watch here. You can manipulate this. You can play around with this. So take this on the other side. So it's the same as saying, where is f of x less than g of x? It's the same thing. I just took the negative over. I took the minus g of x on the other side. So it becomes plus g of x. Yes or no? Guys, you following? So basically, what does it mean? It means where is your hyperbola? Where is your hyperbola below your exponential? For which values of x is your hyperbola below your exponential? So your hyperbola is underneath your exponential. Let's analyze. So this is our hyperbola. That is our exponential. Our hyperbola is underneath our hyperbola is underneath for all those values, for all your x values greater than 3. Let me just double check here. Your hyperbola is also below your exponential for all these values to infinity. It will always, because this carries on to infinity, that carries on to infinity. Your hyperbola, remember there are two hyperbolas. There's one there on the top and one here in the bottom. This is also below your exponential for all these values. For all your x values to infinity, it will always be less. For all your x values less than 0. So for all your x values greater than 3, or for all your x values less than 0, that is where your hyperbola is below your exponential. The last question, the range of f. The range of f, your y values of f. Y is an element of real numbers, but y cannot equal to -4. Why? Because any of your y values, positive or negative, will give you an x value on the graph of f, but not -4. Why? Because -4 was your asymptote. That's how you answer these questions. Lots of fun. You can't fail this if you know your work. You know your parabola. That brings us to the end. I'll see you guys back at 11 o'clock. Enjoy your breakfast break.
Guys, motivated you to come here today?
I was struggling a little bit with algebra, but geometry I'm good with, and I needed some help. And I'm writing paper one on next week, so I came here and it helped me a lot in algebra, and now I understand my work.
Saying that now you understand algebra, what else were you looking at, because we cover a lot of things during the Awqaf workshops and so on. Was there an element of surprise?
Not really, just the functions and the hyperbola graph, which I did not learn at school yet, which I learned here, which helped me. So now when we learn it, then I'll be a step ahead.
Obviously, you'll be a step ahead because these workshops are of paramount importance when it comes to putting the students a step ahead. Would you be able to sort of teach whatsoever you learned here to other students, now having mentioned that there is something that you didn't know of and now you came to learn?
Yes, I will be able to teach other students because now I do know what other students don't know. So when we're learning it and they're struggling, I can help others and share my knowledge around.
Could you perhaps give us a picture, when it comes to the Leadership College, the pure math students there? What kind of students do you have? Playful, serious, intelligent, and not that kind of intelligence, but in terms of choosing what to do and what not to do, the kind of discipline.
The Leadership Community College, they're very hard-working people and they want to work and they progress by working together, which is very good. And they're when somebody's struggling with something, then they'll help each other.
There are obviously students now from the Leadership College who are perhaps watching at you now live from home, those who may be doing grade 9, those who may be doing grade 8, grade 12, who are not here today. What sort of message of hope could you give to them, especially to the grade 12 who are busy with their trials?
I want them to study hard, good luck on their prelims, and I hope they're doing good at home.
And just before I let you go, where do we see Muhammad Kazim in the next 5 years?
Architecture.
Wow, beautiful. And now we've got Renee Rikal with me as well from Al-Azhar College. Renee Rikal, starting from, we've seen a lot of students here from Al-Azhar and the commitment, the kind of commitment, because when it comes to mathematics, sometimes it may be tiring. But we have seen the Awqaf workshops that on Sunday, the students are still there. They still want to learn more. What would you say that has sort of impressed you with the Awqaf SA workshops?
I was really impressed by the commitment of our students, whatever, and I really think we are a very hardworking school and we have the motivation to do our best.
Speaking about the motivation to do your best, what sort of motivation that played a huge role, in getting Renee Rigal to be part of this workshop today?
I'm a part of a lot and I really feel that my marks are what's most important and I should really do my best and try my best.
Speaking of goals, of course, Awqaf SA, the reason why we've got this workshop is to ensure and help students to achieve those goals. Renee Rikal, what do you want to do or who do you want to become in the next 5 to 10 years?
I would like to be studying medicine and to specialize in something.
Why medicine?
Just I enjoy helping people and I find it.
So you enjoy helping people. So when it comes to medicine, there are different faculties, there are different spheres when it comes to the medicine. So would you like to be a nurse, a doctor, or someone who is busy at the lab manufacturing and creating those medicines?
A doctor.
You'd like to be a doctor? Hopefully someone will become your nurse and they will be under your... but just before we close, Renee, were you impressed with this kind of workshop? And was it your first time?
I was very impressed with the workshop and yes, it is my first time.
Ladies and gentlemen, that was Renee Rigal from Al-Azhar High School, and this was Muhammad Kazim making mention to us that they would like to be in the next 5 years prospective leaders in the We don't have that here today.
Yes, certainly. Well done to you, Khalid. I mean, you've been speaking to and we're surrounded by the greatest minds here in South Africa, online as well as in person here. We've got a, a diverse makeup of schools, whether it's Spine Road High School, Oakland's Livingston, we had yesterday, the Leadership College, the list just goes on. And lots of these learners are very enthusiastic. And I think they've got a sound foundation in grade 10 for grade 12. And, in the start of our program, we played the tribute video of William Smith, who passed on, educationist. He dedicated his energy and he was a pioneer to bring this sort of a format, a maths classroom tuition, to the rest of South Africa. And I think he'll be smiling down from the heavens, reflecting on this activity where we bring a cohort of learners over the weekend to prepare them for the examination. Your reflections on some of the enthusiasm and some of the great minds here as part of our cohort?
I'm very surprised with the kind of students we have. I think we've got a cohort of learners, that are willing to learn, that are willing to do those mistakes. And one of those things that was impressive about them is that they actually came to me and offered themselves to do some interviews, something we haven't had, in a while, because we go around asking students who is willing to talk and share inspiration to other students. But the group we have here today, we've got a list of students who came to me saying that I also want to talk. I also want to share my story. And I think that is quite inspirational, and it can only be a motivation for Awqaf SA to continue with these programs. As I asked you yesterday, someone who may not have tuned in or something like that, are we having other workshops?
Yes, certainly. These workshops, and OCAP has a very holistic approach. We host these workshops in May. This is the August edition, preparing learners for the semifinals. And for the final push in October, we will be hosting a October edition. So do not stress. We're going to be with you with this journey. So the key to unlocking great success in your mathematics examination is preparation. So Awqaf South Africa on YouTube, please subscribe. Have a look at the playlist. There's a playlist of lots of the maths workshops for grades 10, 11, and 12, dating back to 2022. So let these videos, and Khalid, on your side, and lots of the team, Samit and team, Nasir, that's on the back end, lots of effort and energy is put into producing some sort of a workshop or a video that is of a decent standard from a production point of view. So you'll be pleasantly surprised that lots of these videos are intended for long or for consumption in the future. So inshallah, so if you have siblings in grades 11 and 12, we have hosted workshops during the course of August. You can have a look. You can log on to Awqaf's website as well, awqafsa.org.za. So that's it from my side, Khalid. I think it's been a very good investment of time over the weekend, and I'll hand over to you.
And that was Hassanain Abdullah, the Awqaf SA project manager, telling us more that if you've got someone at home, who is doing perhaps grade 10, 11, or 12, we've got these workshops that we have been conducting throughout the year. You can log on the Awqaf SA website, which is awqafsa.org.za, and sort of get, those videos, because these videos, the streams that we do make as Awqaf SA are to ensure that it helps students in the long run. So we may be doing a workshop here today at Al Azhar High School, but someone in the next 5 years will still use whatsoever we did here today in order to go on and get that distinction. And that's it from me. My name is Khalid Kungani Kivaspadi. Up until we meet next time at lunchtime, hopefully, where we'll be having the Member of Parliament, Khaled Sayed, with us.
Okay, here we go, here we go. Welcome back, everybody. We are now starting with analytics. Let's go to our onliners. Are we back, guys? We see Offense from Shoshanguve East Secondary School. Welcome. Welcome, everybody. Let's get cracking. Okay, guys, we're starting with paper 2. Let's start with analytics. Let us start with analytics, analytical geometry. Right. With analytical geometry, this is paper 2. And you're going to get a question worth between 18 and 20 marks. Right, let's go. Right, the first formula that we need to know for analytics is your distance formula. Put it down. Between 2 points, let's say A and B, is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Right. The second formula that we have is the gradient formula. And we say the M. The gradient is represented by M. The M of AB is equal to y2 minus y1 over x2 minus x1. Right. Gradient formula, very important. For parallel lines, we know the M of line 1 must equal to the M of line 2. For 90-degree lines, we know that the M of line 1 multiplied by the M of line 2 must equal to minus 1. The product of the two lines must equal to negative 1. Very important. This will be repeated to you multiple times in grade 10, 11, and 12. You're going to do this. You're going to be tested on this till grade 12. Right. The third one that we need to know is the midpoint formula. Very important formula also. The midpoint of a line, to find the coordinates of the midpoint of a line. We know that x1 plus x2, not minus, plus over 2. And y1 plus y2 over 2. We are finding the average between the 2 points, the middle of the 2 points. Right. Then we have the last one, the equation of a straight line. We all know by now y is equal to mx plus c. But if you are given a point and you are given the gradient, then we can use, I'm going to give you a formula, y minus y1 is equal to m into x minus x1. So there we go. There's your point, your coordinates, there's your gradient, and you can bring it into the form y is equal to mx plus c. So many of you have seen this, many of you haven't, but you'll be using this in grade 11 and 12. So you can start using it from grade 10 already. Okay? So learn these 4 equations. This is your toolkit for the entire topic. Now what I'm going to do, I'm going to throw you straight into the deep end because it's only application of formula. Let's choose an exam model from a past paper, from an exemplar grade 10 past paper, as if this is your final exam or a test. So I'm going to choose a model. Probably I'll make, this one is worth 18 marks. I'm going to make it slightly more, probably about 25, 26 marks. I'll add every different scenario you can get about this. And let's get full marks for it. Remember, this is a topic you need to total. Your stats, data handling, mean, median, mode, draw a histogram. But I mean, you've been doing that from grade 10. You get full marks for that. Analytics, full marks. Trigonometry, which we're going to do after this, full marks. Trig graphs, full marks. Euclidean, the last one will always be difficult. So even if you get 80% for Euclidean, it's fine. You'll still get 90% for your paper. Okay, so here we go. Onliners, we back in. There we go. How are we doing, onliners? We're doing well. Lovely. Let's take an exam model. Let's test our skill. Okay, so I'm going to do this. Let's take an exam model. Let's draw this. You can take this down with me. And let's answer as many questions as we can with regard to analytics. Now, just to explain to you, to put you into perspective, analytical geometry used to be called coordinate geometry in our days. They changed the name. They changed the name from because we're only dealing with two pairs of coordinates at a time. You never deal. You'll always see x1, x2, y1, y2. You'll never get x3, y3. Why? Because we're only dealing with how many coordinates at a time? Two pairs of coordinates. Right. So they just give you a diagram like this. They tell you this point is a point D, -3 and 3. They give you a point here, E, 3 on my X, -5 on my Y. Remember, these are coordinates. They are also called an ordered pair. Why is it called an ordered? Because it's always X first and then Y. F, -1 and K. F, -1 on my X and K on my Y. Okay, so there's a diagram. Sometimes they can give you a rhombus. They can give you a parallelogram. They can give you a trapezium. They can give you a triangle. We need to know our properties. Let's quickly go through properties of a... what are your properties of a square? If they tell you it was a square, what are your properties? All four sides are equal. Diagonals bisect. And the lines meet each other at 90 degrees and the opposite sides are parallel. Rectangle, opposite sides parallel, diagonals bisect. That means they have the same midpoint. Very important, because you'll see it's going to come up now later. They're going to give you another point, and if they say if DEFG is a rectangle, find the coordinates of the midpoint, or find D's coordinates. So basically, we need to know our properties. What is a rhombus? A rhombus is a tilted square. The only difference between a rhombus and a square is that they don't meet at 90 degrees. Very good. A trapezium. What is a trapezium? Just to show you here, a trapezium, there's only one quality, one property. It's a quadrilateral. It's not a parallelogram. One pair of opposite sides are parallel. Then we have a kite. Very important. A kite is asked in grade 10, 11, and 12. What are the properties of a kite? The adjacent sides are equal. So it's not a parallelogram. It's a quadrilateral, but it's not a parallelogram. We also know that the diagonals meet at 90 degrees. Very important. Very, very, very important. And the short diagonal, that point where they meet, the two parts are equal, so it's the midpoint. Right? So the long diagonal is the perpendicular bisector of the short. The long line is a perpendicular bisector because it cuts it in half of the shorter diagonal. It's important. All these properties are exceptionally important because you can be tested on these properties as part of your question. Also, we know that the area of a 90-degree triangle is what? Half base times perpendicular height. Right? Good. Now let's start with questions. Let's start with questions. So this is called a trapezium or a trapezium. And this is called a kite. Okay. Let's go. Let's start with the questions, guys. Let's start with the questions. You'll see it's a build-up. And it's very easy. Plug and play. Just application of formula. That's all. Just use the right formula for the right outcome. So they tell you in the story, in the diagram, D, E, F are 3 points on a Cartesian plane. That's your y-axis. That's our x-axis. Cartesian plane, very important because we're going to be using this in trigonometry as well. You know the cast diagram? Yeah, it's coming. Right. So here, the first question, the length of DE. So let's do it question for question. So very simple for 3 marks. The length of DE. So now we have to use the distance. Whenever they ask you for length, we use the distance formula. So we're going to say DE is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, the first few questions are always very easy. They build up to difficult questions towards the end. So, what was that for? DE is equal to the square root of. Now, let's call this one, you can call any one, D and E. Let's call that one x1, y1. Let's call this one x2, y2. So DE is equal to x2 minus x1. Be careful. Minus 3 plus 3 all squared plus y2 minus 5 minus y1 minus 3 all squared. Go straight into your calculators. Go straight into your calculators. You guys can share one. Let's go. Thank you. Let's go. Square root, open brackets. Oh, you can do it. 3 plus 3 is 6. 6 squared is 36. Plus minus 5 minus 3 is minus 8. Minus 8 squared is 64. Your answer is 10. So DE is equal to 10 units. The length, you must say units. You don't say we don't, in analytics, we never use meters, kilometers, centimeters. We just say units. So that means this is 10 units. Go onto your diagram and the answer that you get, put it on your diagram. The more information we have on our diagram, the easier it is for us to answer the preceding questions. Right? Simple, straightforward. They must ask you a gradient question. Let's see what's question number 2. The gradient of DE. The gradient of DE. For another 3 marks. So now we say the M of DE is equal to the gradient formula. You get a mark for the formula. Please insert it. Y2 minus y1 over x2 minus x1. Y2 DE. We're looking at this line here. Please use the correct coordinates. Minus 5 minus 3 over x2 minus x1 minus 3 plus 3. That will give me negative 8 over 6. Simplify that. Minus 4 over 3. Divide by 2, divide by 2. Negative 4 over 3. So let's go to this line. We got the M of this line. Let's go and write the M of the line is equal to negative 4 over 3. Always take your answer and put it onto your diagram. Don't forget that. Because we're always going to be working from our diagram in our later questions. We're not working from our previous calculations. We all okay, grade 10s? Lovely. Next question. The value of K if DEF is 90. Now comes that it's not tricky. You just now need to start applying your mind. Read the question and take out clues from the question. So let's put the next question, question number 3. The value of K, question number 3, the value of K if DEF is equal to 90 degrees. Now, the minute they talk about DEF equal to 90 degrees or perpendicular, your mind must already go to which formula? Gradient. So work it out. Work it out. The value of K if DEF DEF is 90 degrees. So DEF, so they're telling you that's 90. So you can make a square there. They're telling you this is 90. Interesting question. It's worth 4 marks. Not difficult. Not difficult. We know that the m of line 1 multiplied by the m of line 2 must equal to -1. Yes or no? Right. So that's where we're going to begin. Because it's 90 degrees, the m of DE multiplied by the m of FE is equal to -1. Why? 90 degrees or perpendicular. What is the m of DE? We just worked it out. -4/3. Multiply by the m of FE, which is y2 minus y1. So we can call that one x1, y1 again. So y2 minus y1 minus 5 minus k over x2 minus x1 is equal to -1. So y2 minus y1 over x2 minus x1. Now, can you clearly see that we have only one unknown? So here comes your algebra. Here comes your algebra. You need to solve for k. It's an equation. So -4/3 into -5 minus k over 3 plus 1 is 4 is equal to -1. Right. Go ahead. Come grade 10s. Let's see your algebra. It's like solving for x. You need to solve for k. Make k the subject of your formula. Oh, that was something that we forgot to do. Changing the subject of the formula. We'll be doing that. Okay. The minute I finish off with this, it's very easy. It's very, very, very simple. It'll take us 5 or 10 minutes to do. To show you how to change the subject of the formula. That's something that we were instructed. Please show the grade 10s because they're battling with changing the subject of the formula. And you shouldn't. It's simple. You just do the opposite operation. It's an equation. Right, so let's go. Let's divide by negative. So negative divided by a negative is a positive. How do I get rid of 4/3? You multiply it by 3/4. You can multiply it by its reciprocal. So what I do on the left, I do on the right. That and that will cancel. That and that will cancel. I'm left with -5 minus k over 4 is equal to 1 times 3/4 is 3/4. Yes or no? We are making k the subject of the formula. Now we need to get rid of the 4's. So we multiply this side by 4. I multiply that side by 4. 4 and 4 will cancel. 4 and 4 will cancel. -5 minus k is equal to 3. Minus k is equal to 3. -5 will come on the opposite side as +5. Minus k will equal to 3 plus 5 is 8. Divide by negative. Divide by -1. K is equal to -8. And we know we write because it's below my x-axis, it's a negative value. F is below, it's negative. So K is equal to -8. K is equal to -8. There we go. That was simple, but you had to show all calculations. You had to show all calculations. That's how you would get 4 marks for this. Onliners, how are we doing there, guys? Somebody asked, what time is the lunch break? We'll go for lunch at 12:30. Or maybe 10 minutes, maybe at about 12:40. Between 12:30 and 12:40. Right, yes. Negative? No. Negative divided by a negative is a positive. We got rid of the two negatives on both ends. Are you with me? Yeah, I divided, minus 4 over 3 was equal to minus 1. So divide by minus 1, what I do on the left, I do on the right. So negative and negative becomes a positive. Right? No. See here, minus 4 over 3 is equal to minus 1. Now, I divide by negative 1. What I do on the left, I do on the right. Negative divided by negative keeps it a positive. Agreed? Right. Let's go. Next question. Find the coordinates of M, the midpoint of DF. Right. So now they ask you for the midpoint of DF. They want the coordinates of M, the midpoint of DF. So what we do? We go and draw DF. Let's draw DF. Let's join these two. They want the coordinates of M. We don't know where M lies, but we just assume that it's there. So we want, this is question number 4, am I right? The coordinates of M, the midpoint of DF. Right. So M, the midpoint, we're going to say x1 plus x2 over 2, y1 plus y2 over 2. Right. So now we say DF. So x1, and let's call this x2, y2. So x1 plus x2, you don't change the sign because it's plus, over 2. y1 plus y2 over 2. So minus 4 over 2 is minus 2. Minus 5. 3 minus 8 minus 5 over 2. So that's M's coordinates. Minus 2 and minus 5 over 2. There we go. Now comes the 3 last heavy questions. They're not heavy. I promise you, you master this, you're okay. Okay? Let's say they asked you for the equation of FE, the equation of EF or FE. Right, that's also quite simple. Then we're going to do, if they call this angle theta. Interesting. So now I'm going to, you know where I'm going with this. All right, so let's first find the equation of EF. Let's find the equation of EF. Now, in order to find the equation of a straight line, what do I need? I need a gradient and I need a point, any point. Do I have the gradient of EF? Yes, I do. EF, the gradient, is equal to, because these two are 90 degrees. This is minus 4 over 3, so M will equal to 3 over 4. The M of EF is 3 over 4. Why? You change the sign and you flip the fraction. You change the sign and you flip the fraction. So if the old line, that one line is negative, the new line will be positive. If this one is 4 over 3, this one will be 3 over 4. Because if you multiply them, it's going to equal to negative 1. And do you have a point? Yes, I got 2 points. I can choose any point. Let's choose the point E, 3 and minus 5. Now I'm going to use that new formula I showed you. Y minus y1 equals M into x minus x1. Gradient and a point. So let's do this together. Put down your pens. Let's do it together. So now we're going to go. y minus y1 minus minus 5 plus 5 is equal to m 3 over 4 into x minus 3. Now let's remove the brackets. Y plus 5 is equal to distributive law, which we did in algebra, 3 over 4x minus 9 over 4. Now we take the 5 on the other side. Here's your final answer coming up. 3 over 4x minus 9 over 4 minus 5. So go to your calculators. Minus 9 over 4 minus 5 minus 29 over 4. And there we go, mx plus c. So we got the equation of that line, y equals 3 over 4x minus 29 over 4. Done. And you'll get 4 marks for that. Okay. Now let's see. The first one to get this one right, let's see who's smart. We'll give you a cash prize of 50 bucks. 50 rand? All right, here's the 50 rand cash prize coming up. So what we'll do, guys, even if you are online or you are live, at the end of the session, the first person to get it right will come to me. Get it right. No teachers, only for students, because I know there's lots of teachers also part of the program. Only for students. You'll come here to Khalid, and you'll give them your cell number, and we will send you an e-wallet of 50 bucks after the program. Right. So all our cash prizes, will send you e-wallets for it. Okay. So here's your question. If f is equal to theta, find the value of f. If f, so here's your 50 rand prize question. We're going to have a couple of prize questions today. So the next question, question number 6, if angle f is equal to theta, find the value of theta. Show all calculations for 5 marks. Onliners, here comes your 50 rand question. First person to give me an answer here. Who's sharp? If angle F is equal to theta, pick up your hand. If you got an answer, you'll have to come here to the front and show it to me. Let's see. Okay, so we got, I don't know. I haven't worked it out. Have you? Okay, who said, we had somebody there that said 45, and I got somebody also here on, who said, yeah, okay, all right. Let's see.
Okay, guys, please settle down.
Right, here we go.
Online students as well.
Right. Thank you. Here we go.
Just lift your hands up, then I'll come pick you up.
Right, let's go. Sorry. I'm going to go. Remember, I'm going to use trigonometry because it's a 90-degree triangle. So I'm going to use 10. So I need to find the length of FE. So FE is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Fe is equal to the square root of 4 squared is 16 plus 3 squared is 9. Right? 3 squared is 9. So Fe is equal to the square root of 25, which is 5. So Fe is equal to 5. Fe is equal to 5 units. This is equal to 10 units. I'm now going to use, you all know, we're going to use SOHCAHTOA, you know, from Trigs. That's your opposite. That's your hypotenuse. That's your adjacent. So let's go.
Guys, please
Let's
settle
see.
down.
No, it's fine. Leave them. Leave them. Let's see now. Okay, Mango Fish says 63,4. I think Mango Fish is the right one. I think so. All right. So we're not going to use sign. We're going to use 10. Let's use 10. Listen, from SOHCAHTOA. From SOHCAHTOA in trigonometry, we know we need opposite over adjacent, the 10 units and the 5 units. Opposite over adjacent, so we're going to use 10. So tan of theta is equal to opposite over adjacent, which is 10 over 5. So tan of theta is equal to 10 divided by 5 is 2. Theta is equal to... but we got Mango Fish that already gave us the answer online. Shift 10 to 63,43 degrees. The first person... Right. Here we go. The first person that gave us the answer there was our... Okay, so we'll do this. You gave us an answer here of 63. Right? You were the first, 63,4. And Mango Fish gave us of 63. We'll give both of you 50 rand, 50 rand. Well done. There we go. There we go. Well done, well done, well done. Well done. So somebody said there's 45. Right, okay. Shh. Now there will be more, don't worry, relax. Right, let's go, let's go. So now, okay, last question, 2 more questions. 2 more questions to wrap up this. And this in total was 30 marks. The entire question. Right. If D, E, F, G, listen, here's another question. There's 2 more questions here. Shh. So what question is this? Question number 7. 7, eh? Right. If D, E, F, G is a parallelogram, find the coordinates of G. No ways. Right. No. Guys, behave. And number 8. Yes. So just make a note there and get that boy's name there. Right. And the last one, I want the area of triangle. Calculate the area of triangle DEF. For 3 marks. There we go. 5 and 3, 8. 8 marks on these 2 questions. Well done, guys. Well done. Yes, they tell you D, E, F, G. So they don't give you where G is. Now, if it's a parallel, then I'll be giving you the answer. Or a parallelogram. But it doesn't make a difference. D, E, F, G is here. D, E, F. It can't be anywhere else. It's a parallelogram. So that means you got to put G there. You got to draw a line there. And you got to draw a line there. In fact, calculate the area of, let's say D, E, F, G. D, E, F, G. Right. Okay. Now what we do here, guys, they asked you to calculate the midpoint. So guys, don't use gradient, don't use distance. Use your midpoint formula. I'll tell you why, because your midpoints bisect each other in a parallelogram. So do that. Okay, it doesn't go right through there. It doesn't see. I'm just trying to get it as, okay, that's supposed to be a diagonal, right? Right, remember this piece here is equal to that piece and this piece here is equal to that piece. So it's the same midpoint. So G, X, and Y. We're going to use this line, GE. So I'm now going to answer here. I'm answering question number 7. The midpoint, listen, M the midpoint of GE. I'm looking at the line GE. X midpoint is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. Because the midpoint is given. You calculated it earlier before. Agreed? So x midpoint is minus 2, is equal to x1, which is x, plus x2 plus 3 over 2. Y midpoint minus 5 over 2 is equal to y1 plus y2 over 2. Now these two are equations. We just solve for x and y. Pay attention. We're just solving for x and we're solving for y. So times 2 on this side times 2 minus 4 is equal to x plus 3. X is equal to negative 7. Times 2 on this side times 2 on that side. Y is equal to minus 5 plus 5. Y is 0. So G's coordinates is negative 7 and 0. Well done. Sorry? They want to see all calculations. Don't just give your final answer. They say show all calculations. And look how many marks is it. So don't do it by inspection. Don't do it by inspection. Okay. Calculate the area of DEFG. So what you can do, calculate the area of the one triangle and multiply it by both. Okay, in this case, it's a rectangle. But if it was just a parallelogram, you'll have to calculate the area of the one triangle and multiply it by 2. Okay? So you can do length times breadth because this here is a rectangle. Because this is a rectangle, what makes it a rectangle? That is 90 degrees. So therefore, this now becomes a rectangle. So now we say the area of this is now going to equal to length times breadth. So we got 10, we got 5, 50 units square. And there we go, we're done. That's analytics done. Okay, let's quickly do the changing the subject of formulas. I'm going to do, we only follow our laws of equations. It's very easy, guys. I know you guys battling with this at school, but let me show you how easy is it to do. Right, so I'm erasing here, guys. We're done with that. We know 20 to 30 marks guaranteed in our paper. Okay. We call this, guys, we call this literal equations. What do we call it? Literal equations, changing the subject of the formula. I just want to show you this quickly. This is still to do with algebra, changing the subject of the formula before we go into trigonometry. Right, let's check our time. 11:45 already. Right, pay attention. So let's do this. Let's put one here. Let's put one there and one there. Let's make up one. Let's say volume is equal to pi r squared times height. Make r the subject of the formula. S equals n over 2 into a plus L. That's an L. Make L the subject of the formula. Let's say MV equals the square root of n over AB. Make B the subject of the formula. And then I'll give you one more after this. So that's a V. So let's just go here. Let's take that, MV, MV. So they give you three different formulas. You'll only get one of this in your exam. Right. Just think of this. To get to what they want, you get rid of everything that's attached to it using your laws of equations. So what do? We get rid of everything attached to it. So we basically isolate it. And how do we isolate it? By using our laws of equations. That's it. Right. Let's get to R. So the first thing we need to do here, that's our question in our answer. Now we want to get to R, so circle it. Here we want to get to L, so circle it. Here we want to get to B, so circle it. Remember, that's what we're looking for. Okay, so let's go. The first thing, volume equals pi r squared times height. If I want to find r, get rid of, it's pi times r squared times h. What's the opposite of multiplication in equations? Division. So what must I get rid of? Pi h. So pi times h. So that and that will cancel. That and that will cancel. What I do to the right, I got to do to the right. Now pay attention. So now I'm left with r squared. So r squared is equal to v over pi h. I don't want r squared. I want r. What's the opposite of square? Good. So we find the square root. What I do on the left, I do on the right. So here's your final answer. R is the square root. You square root the whole side. V over pi h. There we go. You'll get 4 marks for that. As simple as that. I'll do the second one for you. I want you to do the third one, and I'm going to give you one more to do. The third and the fourth. I want you to do those two on your own. Right. Now we need to get to L in the second one. What's attached to it first? Not the A. What's attached? The n over 2. So how do I get rid of n over 2? Okay, let's first get rid of the 2. What's the opposite of division? So we multiply this side by 2. We multiply that side by 2. So what am I left with? 2s. 2s is equal to 2 and 2 will cancel. I'm left with n into a plus l. Remember, we're getting to l. This is n times. What's the opposite of multiplication? Divide by n. What I do on the left, what I do on the right, I do on the left. What am I left with? A plus L is equal to 2s over n. I want L. I take the A on the opposite side. Plus A will go on to the other side as negative A. So here's your final answer. L is equal to 2s over n plus A will become minus A. That's your final answer, and you got 4 marks for that. You're just using your laws of equations, but you're not given values, you're given alphabets. No problem. We just use our alphabets. That's it. But please use your laws of equations. You know the opposite of multiplication is division. The opposite of division is multiplication. When you take a positive over, it becomes a negative. When you take a negative over, it becomes a positive. The opposite of square is square root. And the opposite of square root is square. The opposite of cube is cube root. And the opposite of cube root is cube. Simple. Straightforward. Do the last one. Now be careful. Let's see how sharp are you. Do number 3. Do number 3. And I'm going to give you one more. Do number 3, and let's do number 4 as well. Rx is equal to n minus AR over 4 make R the subject. Oh no, let's make this AX and then solve for X. AX over 4, solve for X. Or make X the subject of the formula. Here make B the subject of the formula. Here make X the subject of the formula. This will wrap up changing the subject of the formula. We're then going into trigonometry. I'm going to give you what the overview is. And we're going to start immediately with past papers. Now, grade 10 trigonometry is very easy, guys. I swear you can get full marks. It's a topic you ought to look forward to in the exam, not shy away from. Right, let's go, let's go, let's go, let's go. Just said, the host muted your mic. Come guys, do these two. Do these two. Okay. Okay. You ought to be done with number 3. MV is equal to the square root of n over AB. Now we need to get to b. The first thing that needs to move is the square root. So we square this side. The opposite of square root is square. We square the entire side. So that and that will cancel out. What am I left with? N over AB is equal to m squared v squared. Remember, the square belongs to both. Now remember, that's over 1. We want b in the numerator. So we can, in equations, we flip this side, we flip that side. So AB over n is equal to 1 over m squared v squared. Now I need to get to b. Let's get rid of the n. Multiply by n, the opposite of division, multiplication. Multiply by n, what am I left with? AB is equal to n over m squared v squared. And I want b, so the opposite of multiplication is division. So we divide by a, we divide by a. So your final answer is b equals n over a m squared v squared. That's your final answer. Or you can say m squared v squared a. No problem. Same thing. Now let's see you guys do the next one. Let's see you guys do the next one. We've covered already, by the time we're done today, we probably would have covered about 80% of the year's syllabus already. Towards the end of the year, I think we only would need to go through some, we'll need to go through some probability. We need to go through number patterns. But number patterns, I think your teachers will only do in the 4th term. Right, let's do number 4. Let's do number 4, the last one. So Rx is equal to n minus ax over 4. Right, let's multiply. We need to get to x, but let's get rid of this 4. So we multiply this side by 4, we multiply that side by 4. So what am I left with? 4Rx is equal to n minus ax. We need x. So let's take 4Rx. Let's take the minus ax on that side. Will become plus ax is equal to n. That's x. We need to solve for x. We got 2 x's. We factorize. We take out the highest common factor of x. We now left with 4r plus a equals to n. We take out the highest common factor of x. Now this is x times this. We only want x. We divide this side by 4r plus a. What I do on the left, I do on the right. Here's your final answer coming up. X is equal to n over 4r plus a. Learn. They love this question where you got to combine 2 terms and then pull out the highest common factor. Very popular, this style of question. So whenever you have 2 unknowns in an equation, that's the same. And they want you to make it the subject of the formula. You combine it together on the one side, pull out the highest common factor of that unknown, and then make that the subject of the formula. You'll get your answer all the time. You'll use this till grade 12. Okay, onliners? Right, here we go. Let's do the next one. We're now going into, what are we going into? Trigonometry. Let's start with trigs, guys. Let's start with trigs. This is going to take us till lunch. Right, here goes. Right, now remember, for grade 10, we only deal with 90-degree triangles. Right, for grade 10, we only deal with 90-degree triangles. Shh, quiet. What do you need to know for so now in trigonometry, if I gave you a triangle that looked like this, quiet. Okay, you need to know SOHCAHTOA. If you don't know SOHCAHTOA, you can't do trigonometry. You all did SOHCAHTOA at school, right? Oh hell, another hour of algebra. Let's go. Now, this is angle theta. Theta is an unknown angle like X, Y, Z. Shh. Let's just talk about triangle ABC. Number one, step number one, you always need a 90-degree triangle. Step number two, you always identify which is your reference angle. Which angle are they talking about? Step number three, you always complete SOHCAHTOA. You put your opposite, adjacent, and hypotenuse. Opposite, adjacent, hypotenuse. You label it. That's the first thing. That's your golden rule. Right. Now you start answering the question. And you look for a restriction if they gave you. Because the minute they give you a restriction, so I'm going to put a star here, because that's only if they give you a restriction. Then you got to draw your Cartesian plane. Then you know if it's in your first quadrant, it looks like that. If it's in your second quadrant, it looks like that. Third quadrant looks like that. Fourth quadrant looks like that. We know this is A, S, T, C. All positive, quadrant 1. Quadrant 2, sign positive, everything else negative. Quadrant 3, tan positive, everything else negative. Quadrant 4, cos positive, everything else negative. So these are the quadrants in which they live. So basically, sine lives in quadrant 2, he's always positive. Tan lives in quadrant 3, he's always positive. Cos lives in quadrant 4, he's always positive. This is the headquarters. These are three brothers. Sine brother, cos brother, tan brother. This is their plots on a piece of land that they live. Remember, sine lives in quadrant 2 or plot 2, farm 2. Tan lives in farm 3. But at times they can go and visit each other. I'll show you how we're going to do that. Okay. So here goes 90 degrees triangle. Reference angle, label your triangle. And then look for a restriction if there is. Right. Shh. Pay attention now. What do you need to know in order to master? So this is how you do trigonometry. But what are the topics that you need to know to master trigs? Let's put that down. Guys, let's go. Right, onliners, let's go. Okay, so I'm clearing that. So what do you need to know? Number one, you need to know how to complete a diagram on a Cartesian plane. Right? On a Cartesian plane. Right. You also need to know, obviously, SOHCAHTOA. So that's sine, cos, and tan. Sine theta, cos theta, tan theta. We also got to know your reciprocal functions, your opposite functions. So cosec theta is 1 over sine theta. Learn. Because your calculator doesn't have a cosec key. You have to convert it to 1 over sine. Secant of theta, sec theta is 1 over cos theta. And cot theta, cotangent is 1 over tan theta. Good. Then you need to know your special angles. Your special angles are your 30 degree, 45 degree, and 60 degree angles. So how to use them? You need to know how to use them. Then you need to know how to find theta. And whenever you're finding theta, you have to use the shift key on your calculator or your second function key. Shift key on calculator. And then you need to know how to solve equation. So here it's to simplify. Here it's to simplify using special angles. And here is how to solve equations. Trig equations. So if you know this, and obviously your trig graphs, this is the whole of trigonometry. Now we're going to go through each one. And if you notice, the past paper that I'm using here, this one is November 2015. It's exactly in this order. So they ask you one of each in here, and this will build you up. This alone was 22 marks, 22 plus 13 marks on your graphs. That gave you 35 marks. Now 35 marks here plus another 30 for your, or 20 marks for your analytics, plus another 20 for your stats. You're already sitting with about 100 marks, 95 marks. If your paper is out of 150 at the end of the year, you can get full marks. Okay, so here goes. Onliners, I hope you got all this down. We're going to go for a break. We're going to finish this trigonometry. We might not finish everything till break, maybe 12:30, 12:40. And then when we come back, we're going to continue till the end. But you have to master this. It's a big component. Even ask a grade 12. A grade 12 right now, they're writing now tomorrow, prelims, tomorrow and Tuesday. Their biggest worry is trigs. But those of them that have polished their trigs in grade 10 and 11, they're flying. They can't wait for trigs to come. So trigs can be your favorite topic if you know what you're doing, because it's very easy. And if you pay attention to what I'm about to show you now, you're going to love trigonometry. I promise you, you're going to look forward to it in the exams. Let's start. So I'm clearing the frame. You've taken this all down, right? This is going to be 35 to 40 marks in total. 35 to 40 marks. Put up the board. Okay, there we go, there we go, there we go. Right, I'm clearing the frame. Let's get started. Now they give you a diagram. Watch here. Watch here, watch here, watch here, watch here, watch here. They give you a diagram. Here they gave you a Cartesian plane and they give you just a line here. They call that the point P, X, and Y. They call this R the radius. Right. That's what's given. They also tell you ROP is equal to beta. So that's point R. ROP is equal to beta. That whole angle is equal to beta. Question number 1. Right. And they tell you 17 cos beta plus 15 is equal to 0. This is given. Now answer the questions that follow. Question number 1. Find x, y, and r. Find x, y, and r for 4 marks. Question number 2. No calculator, without a calculator, find, question number 1, sine beta. Question number 2, cos squared 30 times tan beta. Question number 3, find ROP, correct to 2 decimal places. Find angle ROP, correct to 2 decimal places. That means you can use a calculator. And that is for 3 marks again. So let's see. You got 4 marks there. You got 2 marks there. You got 4 marks there. You got 3 marks there. Just on this one question, this is 1.1, 1.2, 1.2.1, 1.2.2, 1.3. Just on question number 1, how many marks? 13 marks. We still got more to come because you have to still, remember, we have to still do trig equations. Okay, so let's go. How do we tackle something like this? The first step, number 1, you draw your 90-degree triangle. You drop your perpendicular. Where do you drop your 90-degree? Do you drop it against your y-axis or against your x-axis? X-axis, very good. So now the first thing we do from point P, we draw our 90 degrees. So obviously that's X, that's Y. That's R. So step number 1, you drop your 90-degree line against your x-axis. Step number 2, you put your question in standard form. Put your question in standard form. Now, this is not in standard form. Pay attention. This is important, guys. This is important. So 17 cos beta is plus 15 is equal to 0. So let's put it into standard form. So I'm just going back here. That was analytics. Let's clear that frame. So what did we have? 17 cos beta plus 15 is equal to 0. Right. Let's get this into standard form. Right. We only want cos beta on this side. So this is an equation. 17 cos beta is equal to minus 15. Divide by 17. Divide by 17. That and that cancels out. Cos beta is equal to minus 15 over 17. Yes or no? That's standard form. Now, apply SOHCAHTOA. We know cos is adjacent over hypotenuse. So adjacent is minus 15. 17 is your hypotenuse. So cos beta is equal to minus 15 over 17. I'm just going to write it here again. Cos beta is equal to minus 15 over 17. Now, we always work with beta inside a triangle, never with beta outside. In our final answer, we'll just add 180 to it to get the whole angle. But when we're working, our reference angle must always be inside the triangle. Now, label your triangle, opposite hypotenuse. So that's your opposite. That's your hypotenuse. That's your adjacent. We got cos adjacent over hypotenuse. So we know that this is minus 15. X is minus 15. Remember, cos is, according to SOHCAHTOA, it's adjacent over hypotenuse. So your hypotenuse is 17. Now you use Pythagoras. So put this into standard form. Then use SOHCAHTOA. And step number 4, use Pythagoras to finish it. So step number 1, step number 2, step number 3, step number 4. Before you even start answering your questions, complete your diagram, because you can't use a calculator. So that diagram becomes your calculator. Now remember, sine, cos, and tan, SOHCAHTOA, it's always opposite hypotenuse. It's 2 sides. We short of a third. CAHTOA, adjacent over hypotenuse, you short of a third. Opposite over adjacent for 10, you got 2, you short of a third. The only way to do it is by using Pythagoras. Right, now let's get this. Now be careful now. Be careful, you need y. You need y. So let's go back. Let's clear this. We're going to be using Pythagoras. Right, remember your triangle looks like that. That's y, that's minus 15, that's 17. That's angle beta. There we go. Okay, so now we're using Pythag. So now we say, please start with your hypotenuse. Pythagoras states the square on your hypotenuse is equal to the sum of your other 2 squares on your remaining sides. So now, 17 squared is how much? 17 times 17, 289. Is equal to y squared plus 15 squared is 225. Y squared is equal to 289 minus 225. Y squared is equal to 64. Y is equal to the square root of 64, which is equal to plus or minus 8. Now be careful. This is below your x-axis, so can it be positive? So y is minus 8, not 8. Many of you make a mistake in the exam. You just say square root 64 and you put 8. You get all your calculations wrong. You get your diagram wrong and you get everything after that wrong also. It's negative 8. If it was above your x-axis, would have been plus 8. If your y value was above your x-axis, would have been positive. It's below your x-axis. So what is it? Negative 8. So let's go. Let's go back. Y is equal to minus 8. So now this is our y value here. Our y value. Now our diagram is complete. Our diagram is complete and we get minus 8. So, right. So there we go. We got x, y, r. What is x equal to? What is x equal to? Negative 15. What is y equal to? Minus 8. What is r equal to? 17. Very good. So these are your steps that I wrote in red on the side. Okay, let's answer question number 2. 1.2.1. Sine beta. Please, you guys messed this one up in the exam. Do not find beta. They are asking you for sine beta. Do what the question asks. Sine, according to SOHCAHTOA, is opposite over hypotenuse. So opposite over hypotenuse, minus 8 over 17. And you leave it just like that. Don't convert it to a decimal. They said without the calculator. Don't solve for beta. They want sine beta. They didn't ask you for beta. So you leave it just like that. That's your answer. Sine beta. Or they can ask you for cos beta. Or they can ask you for tan beta. Are you all with me? Right. The next one. Cos squared 30. Now here they're testing you your special angles. What is, okay, so let me write it out here. Cos squared 30 times tan beta. Now, what you can do is, you can, if you know it by memory, it's good. Otherwise, use your calculator. Although they say without a calculator, as long as you don't put decimals, you'll be all right. So put cos 30. Cos 30 on your calculator is how much? Root 3 over 2. So now you write root 3 over 2 squared. Pay attention, multiplied by tan beta. What is tan? Tan, according to Sokotoa, is opposite over adjacent. So it's multiplied by opposite over adjacent. Minus 8 over minus 15. Now, root 3 squared is 3. Over 2 squared is 4. Multiplied by negative, divided by negative is a positive. 8 over 15. You can use a calculator here. As long as you don't give a decimal, they won't know you cheated. So go 3 over 4. Multiply by 8 over 15. 2 over 5. There we go. That's your final answer. And you'll get 4 marks for that. Straightforward, simple. I told you. Complete your diagram. Answer all the questions based on your diagram. Now, find angle ROP. Basically, they want you to find beta. ROP, they want you to find beta. But we're using beta here. All we'll do is we'll just add on another 182 to our final answer. Because we're going to be working with beta in the triangle. We're not working with the entire beta outside. So let's answer the last one. Let's answer the last one. So you can use sine, cos, or tan, whichever one you want to use. I'm going to use tan because it's positive, 8 over 15. So I'm going to say tan theta. You can use sine, cos, or tan. I'm saying tan beta is equal to minus 8 over minus 15 is 8 over 15. So beta is equal to, we use the shift key on our calculator. Shift tan 8 over 15. Shift tan 8 over 15 equals 28,07, 28,1 degrees. But beta is this big angle outside. So we got the small angle here. So to get the big angle, we got to add on 180 degrees. So therefore, beta in this case is 180 plus 28,1, which is equal to 208,1 degrees. There you got full marks for that. You could have used sine, cos, or tan. You'll get the same answer. You have to get, it's one angle. You have to get the same answer for beta. Okay? Now, so this question is now complete. You got your first 13 to 15 marks. They might ask you another 1 or 2 questions on here, but it's exactly using Sokotoa, using the diagram. So what's the process of this? What did we say? What's the first thing we do? Drop our 90 degrees against our x-axis. Then we label it opposite, you use Sokotoa, opposite, adjacent, hypotenuse. Then we put the, whatever they give us, we check whether it's in standard form. If it is, we quay. If it doesn't, we got to put it into standard form and then use Sokotoa, and then we use Pythagoras to finish it. Then we answer the questions on the diagram. So you answer the questions last. You have to finish the diagram. You don't complete the diagram, you can't answer. You'll get 0 for everything. Are you guys listening? It's easy. Now we're going into 3. This one paper gives us 3 trig equations, 3, 6, and 2. 8 or 9 marks only on 3 questions in solving angle theta in an equation. So they allowing you to use a calculator. You need to make theta the subject of the formula. We need to solve for theta. So here goes. Right, onliners, we all good? Right, let's go. Let's clear. Okay, now solve for theta. Solve for theta. Question number 1. Tan 2x is equal to 2,22. That's your first question for 3 marks. Question number 2. Secant of x plus 10 is equal to 5,759 for another 3 marks. Question number 3. Sine x over 0,2 minus 2 is equal to 1,24 for another 3 marks. Total mark. And now I'm going to add on one more. I'm going to try and make it. I'm going to say cosec 2x minus 10 degrees over 3 is equal to 4. For 4 marks. Total marks, 13. There's 4 different equations. If you master these 4, there's nothing that they can give you in the exam that will beat you. This one here, these 4 types, master them. Right? Now remember, you can't remember your angle. You must always circle your reference angle. Whatever is next to your sine, cos, and tan, that becomes your reference angle. That's your angle. That's your angle. Next to x, so that's your angle. This whole thing here is your angle. Whatever is next to your trig function is your angle. Okay, so let's do it. Come guys, I'll help you through it. We'll do all 4 together. Pay attention to the way we do it. Right, so let's put our answers here on this side. Answer to question number 1. You see, there's nothing, there's no coefficient in front of 10. So you go straight into your calculator. That's your angle. So 2x is equal to, your reference angle is equal to, shift 10. Now go to your calculator, go straight and use your shift key. Shift 10, 2,22. Shift 10, 2,22, 65,75 degrees. So now x is divide by 2, divide by 2. 32,875. And they said correct to 2 decimal places. 32,88. And there we go. 2x, your reference angle is equal to shift 10, 22. Please be careful. Learn these 4. I beg you guys. You really want to get full marks in your exam. Learn this. Let's do the next one. Secant. Does our calculator have a secant function on it? No, it's only got sine, cos, and tan. So what must we do? Convert it. It's our reciprocal function. Okay? Here we go. Let's answer question number 2. Let's answer question number 2. Let's answer question number 2. Secant of x plus 10 is equal to 5,759. Now, watch here. Put down your pens. Secant is 1 over cos x plus 10. Remember, reciprocal functions is equal to 5,759 over 1. That's how you start it off. Now you want cos on the top. So you flip this side, you flip that side. So what am I left with? Cos x plus 10 is equal to, if I flip this side in an equation, I got to flip that side. 1 over 5,759. Now we use our calculator. Shift cos of that. So x plus 10, our reference angle, is equal to, let's go to our calculators, shift cos. Shift cos fraction, 1 over 5,759. I get 80 degrees. Now I solve for x. X is equal to 80 minus 10. X is equal to 70 degrees. I beg you guys, learn. Change the secant to 1 over cos, then flip both sides, then use your calculator, then solve for x. You can never solve for x from the start. Let's do number 3 and 4. Let's do number 3 and 4, and then we are done. That means we got full marks. This was your entire component for trigonometry in your final exam. Simple. But you need to know what you're doing. Otherwise, you're going to stuff it up royally.
Mr. Kota, is the maths matching today?
Why?
I smell a distinction.
Why? Let's do number 3, guys. Sine x over 0,2 minus 2 equals 1,24. We need to make sine x the subject of the formula. Again, here comes subject of the formula. What must move first? I can't hear you. Minus 2. Very good. Very good. The negative 2 needs to move first. Let's go. So sine x over 0,2 is equal to 1,24 plus 2 is 3,24. Right, what's the opposite of division? Because remember, we need to get to sine x. Good, so we're going to multiply the left by 0,2. What I do to the left, I need to do to the right. So what am I left with? Sine x is equal to 3,24 times 0,2. What do I get? 0,648. Fantastic. Now we solve for x. Shift sine 0,648. We use the shift key on our calculator. Shift sine 0,648. Boom. 40,39. Beautiful. Give yourselves a nice round of applause. Right. 50 bucks to the one who gets the last one right. $50. Here comes your 50 Rand question. Onliners, this is the last question before break. So the last 50 Rand, it's up for grabs. That's over 3. And that's a 4. Let's go.
Hard cash, up for grabs.
Let's go, let's go, let's go. That's the last one. Guys, let's see. A mango fish, you seem like a teacher, brah. Mango fish, are you a teacher?
Attention, Mr. Kota. Mr. Kota, hands up.
Oh, we got an
In-house.
answer here. We got an answer. Let's see. You guys got to type it in. Onliners, you got to type it in. Let's see what's the answer there.
47,
What answer do you have?
47.61.
All right. Remember that, right? 47. So she gets 47,61. Let's see.
Drum roll.
Somebody got a different answer there?
Give it a go.
Right, give it a go.
That's 5. 5.
Mr. Kota, 5.
Can't be far. I don't know. Let's check. Let's do it together. Any
Come on
other
now,
takings
guys.
here? I'll give another 30 seconds. Another 30 seconds. She got it right? Is it wrong?
Okay, let's monitor our online.
Okay.
Let's monitor our online
Onliners,
code.
are you giving us any answers here? Come on, guys.
I can smell that crisp 50 Rand note.
Yahya also gets 47,61. Let's see. What do you get?
12.02.
Sorry?
12.02.
12,02. I don't know. Let's check. 12,24. I get.
We're getting hot.
And there I get.
52.5.
Ya salam. Everybody's getting different answers. I'm getting. Right, let's see. Are you ready?
Okay, 1 minute, Kota. Hold up. Mr. Kota, you need to monitor the online code.
I'm
okay?
checking.
We have a right on our hands there. There we go.
Yeah.
Never mind, I got that wrong.
50 on its way. 50 on its way. Hold up, Mr. Kota.
32,62.
Okay, so we've got our onliners. One is saying 12,24, 47,61.
Okay, I'm running out of juice here. I'm waiting for that burgers. Okay, here we go. Give the lady the mic.
42,76.
We get 42,76 there as well.
Okay, we got a hand up here.
Okay, let's check.
more,
Let's
one
check.
more.
Let's check.
One more.
Right, so cosec 2x minus 10.
32,61.
Let's check.
That rounds up my park run now, eh? Let's monitor, Khalid, the online code.
Let's check. Only one correct answer.
Drum
Right.
roll.
We multiply this side by 3. We multiply that side by 3. No, it was 4. I was busy working. The original question said 4. Right, so let's go. So we left with cosec 2x minus 10 is equal to 4 times 3 is 12. 1 over sine 2x minus 10 is equal to 12 over 1. Sine 2x minus 10 over
Guys,
1
please settle down. We've got
is equal
online
to 1
students who can't
over
hear Mr.
12.
Kota.
2x minus 10 is equal to shift sine 1 over 12. I get 4,78. 2x is equal to 4,78 plus 10. 14, you can't give me an answer now. 14,78. So x is equal to 14,78 divided by 2. Are you only telling me now? You're not getting it. Who? I didn't hear 7,39. There wasn't a 7,39. No, you only told me that at the end. Yo, check the guys. The onliners are giving us 5,79, 2,56. Nah, you guys are way out. Sorry, nah, nobody gets us 50 Rand. We'll have another challenge after break. Guys, we're going for break. It is now 25 to 1, 1:15. I see you back in session. Enjoy your break.
We are live at Al-Azhar High School in Athlone, Cape Town. The Awqaf SA Grade 10 Pure Maths Workshop, Day 2. We're doing Paper 2 today. It's exciting times here at Al-Azhar High School. The students are beaming, as Mr. Kota will say, that maths is mathsing. And we spoke to a few students earlier during the commercial break, and one of them was Muhammad Kazar, who made mention that this workshop has sort of helped him, shape up, his maths and algebra or something like that, making a statement that these sort of workshops are quite helpful. When I asked him, Muhammad, what do you want to do, or where do you see yourself in the next 5 years? He said that he wants to be an architect. And one of the students was Renee Regal from here at Al-Azhar High School in Athlone, who also made mention that she wants to one day become a doctor, and the workshops that Awqaf SA has been conducting are quite helpful. Now, it is of paramount importance that we also make mention that it's not just a grade 10 workshop. We've got grade 10, we've got grade 11, we've got grade 12 workshops that are carried out by Awqaf SA. So in case you've got a student who is busy doing those grades, they can log on at our website at awqafsa.org.za, and you can go to our YouTube as well as our Facebook, where you will see information pertaining to those particular workshops. And now I would like to invite Mr. Parker, who is a retired school teacher and a principal, a pioneer, in this field of mathematics. Mr. Parker is one of, should I say, the teachers of Mr. Kota. Mr. Kota was conducting and facilitating the workshop here today. Mr. Parker, welcome to Awqaf SA's Grade 10 Pure Maths Workshop. How have you found the workshop today?
I would say that I've noticed that the learners are all participating, they're exciting, and when Mr. Kota offered the 50 Rand reward, it was more excitement and more games for them to play, and it was, for them, it was something that they've never seen before, and I think they are learning quite hard, and I thought the questions are graded by Mr. Kota in a very nice way, from the Bloom's taxonomy, knowledge, routine, and then complex, and then, of course, problem solving. The last question was a problem solving question, and I think it got the learners a bit, because the question was, it's not on the board anymore, but it's a trigonometric question. We had to calculate, you must use calculators to find the value of x, and of course, some of them struggle with it. It shows maybe they haven't done it properly at school yet, or maybe they're still doing it, but I think with Mr. Kota's explanation, I'm sure they have mastered the concept.
Speaking, of the excitement of the students and so on, how important is it to make sure that pure maths is quite exciting? Because in the past, there has been a perception, or maths has been branded as one of those subjects that fits for nerds and people who are geniuses and so on. How important is it to make sure that maths, in as much as it is a serious subject, but it's also kept the fun part of it?
Well, maths is a subject of discipline. It opens all the doors to all avenues. It's the golden key to all avenues. If you don't have maths, you can't think. That is what my professor told us when I was doing maths. And obviously, you're better think as well. Not I'm saying that maths you can't think, but obviously the difference between the two is that you get a thinking person and a non-thinking person. So the gaps between maths and maths literacy, obviously when you apply for a job, being a high school principal as well, I know that the people look for maths people first. Even though if you get an A for maths literacy, they will rather take on a learner with 40% in maths or 50% maths, making sure that they know something that will be able to do the job. Because sometimes you find learners that can't do maths, but they want to do maths literacy, or maybe the other way around, because of their peer pressure, or maybe from their friends, from parents, they appear, they follow the friends. They can do maths, but they don't want to math. So obviously they lose out in life. Maths required in all the most important faculties: engineering, science, medicine, dentistry, pharmacy, agriculture, sorry, not agriculture, architecture, etc. So you need to get math and accounting, which is very important. You may not do a maths accounting at high school level, but to become an accountant or see a chartered accountant, you have to do mathematics. You can always learn accounting at university. So, okay, fine. So
We always make mention, that when it comes to mathematics, we need those accountants, we need those doctors, we need those architects. How important also is it to make sure that we do encourage students to become teachers of mathematics as well? Because in as much as we want those accountants and so on, if we don't have the teachers to teach mathematics at high school level, then we are doomed. How important is it that we also encourage the students to become good mathematics teachers?
Well, I agree with you. If you don't have a region of learners from a particular pool of learners, then obviously you are going to be doomed to disaster and failure. Maths is the key to Gold Avenue. I said it opens all the doors. So you need to train as you teach learners. You encourage them, motivate them to tell them, why don't you become a good maths teacher? You can always earn a good, better money. Of course, you can go up in promotion posts at the department, at the school where you're teaching at. And obviously that by not becoming a maths teacher, you are neglecting the society in the country, because why? Without mathematics, you can't go further, and you can't do too many degrees either. Therefore, maths is absolutely essential in all the faculty. In fact, when I remembered in 1994 or 2004, UWC insisted and UCT insisted that the law students must do mathematics. They can't get into law unless they have a pass in maths. It happens at Joe Slow High School. I was principal there. A boy got a good mark in maths literacy. He got an A for maths literacy, and he thought he'd get into law at UWC. Unfortunately, he was not accepted. They told him to go back and go do maths, but now I believe it's changed. I do not know how true it is, but I mean, I retired 8.5 years ago as a school principal and a maths teacher for 48 years, so maybe things have changed.
Mr. Parker, as a legend, just before I let you go, I believe on Tuesday, the grade 12 students will be starting with their prelims. What sort of message, as a former principal yourself, could you give to them, and what sort of advice would you give them up front, going to those prelims on Tuesdays?
Well, the most important recipe to pass mathematics well, practice, practice, practice. That is the recipe maths. You work through a lot of old exam papers. You do not look at the paper. When I teach my learners, I tell them, we do revision, don't look at your books. You put the question on the board and tell them, do it without looking at the book. If you can master the concept, you can master that question, you don't have to study that for the examination. Go on to the next chapter, and so on and so on. But the best recipe to do well is to work through old exam papers, as many as you can, from the different departments as well. Gauteng, especially Gauteng, KwaZulu-Natal, Eastern Cape, North, West Cape, because the panel of examiners are most from those areas there. And therefore, they all come together and they sit together and they combine to form a paper. So obviously, the best way is to work through all exam papers to do well and practice, especially geometry. You can't understand geometry if you don't understand the theorems. You apply the theorems and you apply for the right. And then obviously, that's how you solve a geometry problem.
And that is Mr. Parker, a retired school teacher and a former principal who's got vast knowledge and experience when it comes to mathematics, saying that...
Well, can I just say something? I'm actually helping out at Azza High School. Last year, we had 100% pass rate. The year before that, 99% pass rate. One learner was very lazy to get to school. And the highest mark at Azza last year was 93% for learners that struggling. And I mean, we're in the disadvantaged area, disadvantaged school as well. So I always say that if the learners can work hard, there should be no problem. They shouldn't look for excuses like they come from poor areas, there's nothing in their school, whatever. It's their mind that must drive them to work hard. Hard work, commitment, and dedication will be surely success to mathematics and a good mark in maths.
Hard work, good hard work and commitment are some of the things which or some of the tools or the main tools precisely you need, you know, as a student in order to succeed. When we asked Mr. Parker earlier to give an advice to those grade 12 students who will be writing their prelims, he said that practice, practice and practice. So we need to make sure that we without looking on your book, then you are good to go for your examination. And that's where we ended with Mr. Parker, a retired former school teacher and, you know, a principal who is currently helping out here at Al-Azhar High School, making mention that they had a 99%, you know, pass rate, 100% rather pass rate last year. So we need to make sure that we try by all means and encourage students to go on and get those distinctions, because that is the most important thing. With myself, Khalid Kungani Kivaspati, for now, that's where I will leave you.
Many who struggled with maths found a guiding light in William Smith's teachings. His work empowered students to overcome challenges, achieve academic success, and pursue careers they once thought were beyond their reach. Many have gone on to become engineers, computer scientists, and other professionals who credit their success to William Smith's teachings. At Awqaf SA, we are inspired by William Smith's dedication to education. We continue his mission to empower learners across the nation with our maths upgrade programs, ensuring a bright future for the youth of South Africa. Rest in peace, William Smith. You have served our country with distinction. Your legacy will continue to inspire and uplift generations to come.
You got this, grade 10s. Here we go. We are back in session. Hope you guys enjoyed your lunch. We had an extra 15-minute break. Waited for people to finish their salah. And we are back in session. Guys, this is the graveyard shift, the last session for today. And yeah, we got a big push ahead. So I'm clearing the frame here. I'm giving you one more component for trigonometry. Let's check this one out, guys. So they gave you 4 cot theta plus 3 equals 0. And they tell you that theta is less than 180, but greater than 0. Now they give you one with a restriction. Yeah. Yeah. Put up the screen. Put up the screen. It's coming up. It's coming up. There we go. Welcome back. Welcome back. Welcome back, guys. Right. Use a sketch to determine the following. Do not use a calculator. So find the following without the use of a calculator. Right, question number 1, cos theta. Question number 2, 3 sine theta, sec theta, secant theta divided by tan theta. Right, number 3, hence show that sine squared theta minus 1 is equal to minus cos squared theta. Four marks, and 3 marks. So this first question, 4 marks, and 3 marks. Total marks, 11. There we go. Onliners, take this one down. Take this one down. Welcome back, everybody. Okay. In our answer. Right. Take this down. We're doing one complete component worth 20 marks. Let's go, let's go, let's go. We're still finishing up trigs, and then I'm going to give you 2-dimensional trigs. Then maybe I can show you how to sketch your trig graphs, and then finance. If we have enough time, we'll do Euclidean. Let's go, guys. Okay, the first thing we need to do is put this into standard form. So we're going to go 4 cot theta is equal to -3. Cot theta is equal to -3/4. Now remember, we got to change this to tan. So cot theta is 1/tan theta is equal to -3/4. So tan theta over 1 is equal to -4/3. So there we go. We first, step number 1, we got it into standard form. Okay. Now we need to look at our restriction. They give you a restriction. So you can't draw your triangle anywhere. They say less than 180 but greater than 0. So it can only be in the first or second quadrant. It can only be in your first or your second quadrant. Now from these 2 quadrants, where is tan negative? Remember, all is positive in our first quadrant. That means, where is tan negative? Tan is negative tan is negative between these two quadrants, only in my second quadrant. So there's theta. There we go. Remember, you have to draw your triangle in the right quadrant. So standard form, look at your restriction. Now this is theta. Tan is opposite over adjacent. So opposite over adjacent. Now, pay attention. This can't be negative. It's above, so this is 4, not negative 4. But to the left of this is negative 3. It can't be positive. Remember, positive 4 over negative 3 is the same as negative 4 over 3. But it's very important where the negative goes to. You can't go and say negative 4 over 3. You'll get it wrong. This is 4 over negative 3. Now we use Pythagoras to find our hypotenuse. So we know 3, 4, this here will be 5. So we know h squared is equal to 4 squared plus negative 3 squared. H squared is equal to 16 plus 9. H squared is equal to 25. H is equal to 5. So there we go. H is equal to 5. So we use Pythagoras to finish. So it's very important that you complete it. So standard form, Cartesian plane, restriction, and Pythagoras. So you can use this acronym called SCRAP. It will help you to remember the process, the methodology. Standard form, SOHCAHTOA. Draw your Cartesian plane. Look at your restriction to determine where to draw the triangle. A is just for and then P obviously is Pythagoras. So whenever you're drawing a triangle, you can use this acronym called SCRAP. It will just help you to remember the process, what step to do. What's your steps? Okay? Standard form, Cartesian plane, restriction, and Pythagoras. Standard form, Cartesian plane, restriction, and Pythagoras. Don't forget that. So whenever you're drawing a triangle, just think SCRAP. You scrap it. Now we answer the questions. Now let's answer question number 1. Now we just use SOHCAHTOA for all of them. We just use SOHCAHTOA for all of them once we have completed our diagram. So now let's remove that. Let's answer question number 1. We've got our diagram complete. All this was to complete our diagram. Right, now we go. Question number 1, cos theta. Cos theta, we know according to SOHCAHTOA, just remember C-A-H, C-A-H. So cos theta is equal to, that's your opposite, that's your hypotenuse, that's your adjacent. Adjacent over hypotenuse, minus 3 over 5. And that's where you leave it. They don't ask you to find theta. They ask you for cos theta. So answer the question. Remember, the question wants cos theta. Imagine they give you 4 marks for that. Just for this. 2 marks here and 2 marks there. Okay? Next one. Next one. Now, you don't need to wait for me. You can start with number 2 already. You can start with number 2 already. Right, number 2. 3 sine theta times sec theta over tan theta. Right, so we're done with question number 1. Done. Question number 2. 3 sine theta is opposite over hypotenuse, 4 over 5. Sec theta is 1 over cos theta, 1 over sec. We know secant is 1 over cos. Right? So 1 over cos, 1 over adjacent over hypotenuse, minus 3 over 5. That's your cos. Divided by tan theta, opposite over adjacent. Tan theta, remember, all we're doing is we're using SOHCAHTOA. So it's 4 over negative 3. Guys, from here, you can use your calculator. Go into your final answer, but please, no decimals. No decimals. So make sure your calculator work is correct. So 3 open brackets, fraction, 4 over 5, close brackets, open brackets, fraction, 1 over fraction again, minus 3 over 5, go to the side, close brackets, equals, let's divide that by, open brackets, fraction, 4 over negative 3, close brackets. Final answer, yes, well done. Well done. Your answer is 3. Good. That's it. You got 4 and 4. You got 8 marks already. You got 8 marks already. Don't worry. After you substitute, they don't want to see all the algebra afterwards. If you just give your final answer, but as long as you don't use decimals, you'll get your marks for it. Hence show that sine squared theta minus 1 is equal to minus cos squared theta. So what is sine squared theta minus 1? Again, SOHCAHTOA. Here we got to prove that the left-hand side is equal to the right-hand side. So let's do this. Right, so I'm removing here. We're answering question number 3. You got to show that. You got to show that sine squared theta minus 1 is equal to minus cos squared theta. So what is sine squared theta? What is sine theta? Sine theta is 4 over 5 squared. Don't forget the squared. Minus 1 is equal to minus, what is cos? Cos is minus 3 over 5 squared. Now let's show that left-hand side is equal to right-hand side. We need to prove. This is not an equation. You're not solving for anything here. You're just showing that the left-hand side is equal to the right-hand side. So what is this? 4 squared is 16. Over 5 squared is 25. Minus 1 is minus 3. Minus 3 squared is 9. Over 5 squared is 25. So 16 over 25 minus 1 is minus 9 over 25 is equal to minus 9 over 25. Therefore, your left-hand side is equal to your right-hand side. This is how you answer this question. And there you go. You've got 11 marks guaranteed. That's your first 11 marks for this trig component of your paper. Okay. Now they give you one simplifying using your special angles. And they give you one trig equation. So let's answer these two. 4 marks and 4 marks. Another 8 marks. So 11 plus 8, 19 marks. Onliners, how are we doing? Did you get them all right? Here we go, here we go, here we go. I told you guys, pretend that this is final exams and we're just writing the whole final exam together as one big group. Right, let's put the 2 questions up for you. So the first one, simplify without the use of a calculator. Take this one down. Here's the first one, simplify. No calculator, cos 30, 10 times tan 60 degrees, plus, I'm just going to write it here because I don't have space, cosec squared 45, be careful, times sine squared 60. 4 marks. Show all calculations. That's your first one. See if we can drop the echo. And here goes the next one. Solve for theta. Correct to 2 decimal places. That means they're telling you, you are allowed to use a calculator. 4/3 sine theta is equal to cos 37. So 2 questions for us here, guys. One on the left, one on the right. 4 marks each. 8 marks in total for these 2 questions. Now, guys, this is going to wrap up our trig component. I'm then going to do one where they give you a triangle. Let's see, there's some nice ones coming up here. So do this one. Okay, let's see. The first one. Cos 30. Now you can look, although they say you can't use a calculator, these are special angles. As long as you write your answer in third form or fractions, you're okay. So cos 30 is √3/2. Tan 60 is √3/1. So it's multiplied by √3/1. You just substitute plus. Now cosec squared 45 is 1/sine squared 45 times sine 60 is √3/2 squared. Now you're going to get a mark for this. Now, √3 times √3 is 3/2 times 1 is 2 plus 1/sine 45 is √2/2 squared, or 1/√2 or √2/2 times √3 squared is 3/2 squared is 4. They want to see this, guys. You have to show. You can't go from question to answer in one step. They'll know you cheated. You got to show them that you know what you did in each part. So now this is 3/2 plus. Let's go to our fraction. Let's say fraction. Open brackets fraction. 1/fraction. √2/2. √2. Where's your square root here? √2/2. Go to the side. So wait. So let's go fraction without the bracket. 1 divided by, now we open the bracket in the denominator. So it's √2/2, close bracket squared. You get 2. This on your calculator, if you do it properly, you'll get 2 times 3/4. This is equal to, now you can give your final answer. So go fraction, 3/2 plus 2 times 3/4. Step by step. Your final answer again in this situation is 3. There you go. You got 4 marks. 1 mark, 2 marks, 3 marks, 4 marks. Step by step. You get 4 marks. Did you all get 3? Onliners, did you get 3? Okay, good, 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 good. Let's do the one on the left. Be careful with the one on the left. So now we need to get rid of the 4 over 3. So multiply this side by 3 over 4. Multiply that side by 3 over 4. That and that will cancel. That and that will cancel. What am I left with? Sine theta is equal to. Now go to your calculator. Say cos 37, close brackets, multiplied by 3 over 4. Boom. You get 0,59897 blah, 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 blah. Now we need theta. So theta is equal to, because we're looking for an angle, we use the shift key. So shift sine, go cancel your calculator, shift sine 0,59897 equals 36,796. And they say correct to 2 decimal places, so theta is equal to 36,8 degrees. And there we go. You got yourself your next 4 marks. Please, guys, learn all these examples. Practice on all the examples we've done today. You'll be all right. You'll be able to answer any question paper. Now let's do a 2-dimensional, let's give you a diagram. They'll give you a diagram. Onliners, did you get that answer? Yes, yeah, you got 3. Well done. Well done, well done, well done. Let's go. You've taken this down. Now take down this diagram that they give you. We're not doing that on a Cartesian plane anymore. We're now doing a real life situation. So basically what they'll tell you, they'll give you a diagram that looks like this. So they'll give you a nice 90-degree triangle like this. They'll tell you that this is a street light or a pole. In fact, let's not do this one here. Wait, I need to remove this entire thing. I need to clear the frame. Take this one down. There we go. From there to there, from there to there, from here to here. So this is a pole, and it's got 2 cables that are tying it to the ground. That's 90 degrees, that's 90 degrees. This point is point R. The angle of depression is 47 degrees. They call that the angle of depression. That's why they put this dotted line, because angle of depression is straight ahead down. Angle of elevation is where you're looking straight ahead up. Right? So imagine, I'm just going to do it here on the side if you get confused. Right. If you're looking straight ahead, a dotted line going straight ahead up, that angle is called the angle of elevation. Where you're looking straight ahead, down, that angle is called the angle of depression. Like what most of you are going through right now with math. Right. This is 21 meters. This is P. That's angle theta. That's angle Q. Let's call it Q1, Q2. This is 17 meters, and that is S. Let's see. Now they ask, that where you're looking straight ahead will always be parallel to the ground. It will always be parallel, so you'll always have alternate angles. Right, here's your questions. Write down the size of theta. So calculate theta. Number 2, the length of RQ. Question number 3, the size of S, of angle S. If P, Q, and S, if P, Q, and S are in a straight line, if P, Q, and S are in a straight line, calculate the distance PS. Find the length of PS. Here we go. So take this one down. It's worth 10 marks. So probably you'll get your 25 marks on normal trigonometry plus another 10 marks here. That gives you a total of how many marks? 35 marks. Okay. It's a lot of marks. You can't afford not to learn this topic for your exam. And you can't afford to throw away marks here. Okay, let's answer the first question. Calculate. Now again, this is very easy. Theta is alternate to the 47 degrees. So immediately our first question, theta is equal to 47 degrees. Why? Alternate angles. There we go. Find the length of RQ. So what did I say? Whenever you have a 90 degrees, opposite, hypotenuse, adjacent. What are we going to be using to answer the diagram? Sakatawa. Right? So let's go sine of 47. So to calculate RQ, I'm going to say sine of 47 is equal to RQ over 21. Opposite over hypotenuse. RQ over 21. We want RQ on its own. So times 21 times 21. RQ is equal to 21 times sine 47. Let's go to our calculators. Remember, opposite over hypotenuse. So 21 sine 47. You get 15,35. Let's say 15,4. 15,35. 21 sine 47. We get 15,35. Let's say 15,4. Here they don't say to 2 decimal places. So let's say 15,4. Right, so RQ is 15,4 meters. Because they're talking about meters. Everything now is in meters. Calculate the size of angle S. Now they want that. So again, that's opposite. This is hypotenuse. This is adjacent. I'm going to use, to answer question number 3, I'm going to use tan of S. Let's go. I'm answering question number 3. I'm going to say tan of S is equal to opposite over adjacent. So tan of angle S is equal to your opposite, which you just found, 15,4, divided by your adjacent, which is 17. So angle S is equal to, we use the shift key. Let's go straight to our calculator. Shift tan 15,4 over 17. I get 42,17 or 42,2 meters. Degrees, not meters. It's an angle, degrees. There we go. So we got 42,2 degrees. There we go. Right, let's now do the last one, guys. If P, Q, and S are in a straight line, find the length of PS. So that means we need to first find PQ. PQ plus QS will give me PS. Remember, PS is PQ plus QS. We got QS, 17. I need to find PQ. Again, you can either use Pythagoras or you can use trigonometry, whichever one you want to use. It's up to you to find PQ. What do you guys want to use? Pythagoras. All right, so then but why? No. Look how easy this is. I'm going to use tan of 47. Tan of 47 is equal to 15,4 over PQ. So PQ over 15,4 is equal to 1 over tan 47. So PQ is equal to times 15,4. So it's 15,4 over tan 47. PQ is equal to. Right, let's go. Fraction 15,4 over tan 47. 14,36 or 14,4. So therefore, PS, answer the question. Therefore, PS is equal to 14,4, which is PQ, plus QS, plus 17. 31,4 meters. There's your final answer, guys. And you've just used SOHCAHTOA to completely solve the scenario using trigonometry. Okay? Just to give you guys an example, I don't know, maybe if you guys had joined the workshop before, if you want to know, they worked out a couple of years ago. Just watch this. I'll just show you something interesting, how this is used in real life. How this is used in real life. So, many years ago, I'm talking about the early 2000s, right? So if this was this was Ellis Park Stadium. This was Ellis Park Stadium. And there was a dude sitting in here cheering in the crowd. Then there was a building here outside in Hillbrow, because Ellis Park is near Hillbrow. Pay attention. And this is a true story. Right. There was a building there. And there was a guy that stood in the building and he shot a bullet in the air. I don't know, maybe he was khatak or something. Right. So he shot a bullet in the air. Right. So basically what he did is he shot and it killed the guy here in the stadium. Now forensics had to find out exactly where did the bullet come from. Now remember, if this was his head, if that was his head, and the bullet entered at a certain degree into his head, right, they then calculated the speed at which, obviously they had to use the speed, distance, time. So they used ballistics. They had to calculate the speed. So firstly, they calculated the angle to the ground. So that angle there is called angle theta. Then they calculated at what speed. So they calculated this distance here. Right. They knew that it came from the building outside. So all they did that. They calculated this length. They calculated this distance. They had the angle, they used trigonometry to find and they found the exact flat or apartment from which, and they nabbed the guy who actually shot the bullet. So you use trigonometry, you can use trigonometry in real life situations for ballistics, for forensics, especially for ballistics. Even if you know the caliber of gun, those of you who go hunting, and you want to shoot a buck or kudu or something, you need to know, you can calculate the distance between yourself and the kudu, or whether the bullet will actually hit a kill shot so that you'll be able to kill that kudu. So just to put you into perspective, that trigonometry is used, you seeing it as mathematical, but yes, it is mathematical, but it's used heavily in real life processes too. They use it also in submarines, they use it in ships, they use it with periscopes, they use it for missiles, for rockets, everything. All right, so it's used heavily. Okay, so that puts you in the picture with that. Okay, let's go into, how much time do we have? Let's quickly go into your trig graphs. Let's go quickly into your trig graph. So your sine graph, just remember your sine graph, S for sine, S for starts at 0. It will help you to remember that your sine graph starts at 0. C for cos, C for cuts first. So it will start at your amplitude. It starts at your height. And just remember, S sine start at 0, C cos cuts first, and just remember, and tans S, because it's got asymptotes. Asymptotes at 90 degrees and 270 degrees. Right. So if they told you to sketch the graph, f of x is equal to 2 sine x, for x being an element of, let's say, minus 180 to 360. Let's start with the sine graph. So let's draw our swimming pool, our axis like our swimming pool. Right. The diving board is the height, that's called your amplitude. So it's going to go up to 2 and down to minus 2. The length of your swimming pool, 90, 180, 270, 360. And minus 90, minus 180. It's a sine graph, so it starts at 0. So let's go to 0 and put a dot there. Right. So you can picture a dolphin, right? So if you go to the aquarium, this is a dolphin. You get a sine dolphin, a cos dolphin, and a tan dolphin. The sine dolphin starts at 0. And because it's positive, it will go 0 up. Right. So it goes up. Now, to get the step of your graph, where is the changeover of your graph? How do you calculate that? To calculate your step, you know there's a number here and that's 1. It could be 2, it could be half, it could be whatever. So 90 degrees divided by that number is equal to the step. So 90 degrees divided by 1 is equal to 90. That means every 90 degrees, or 90 meters, this dolphin is going to make a change. So he's going to jump up to a maximum height of 2 at 90 degrees. He's going to go up in the air. He's going to turn. The next 90 is going to hit the water. The next 90 is going to come. He's going to turn under the water. And he's going to stop there. And now he just continues the pattern on the opposite side, because remember, this is your domain. That's not the period of the graph. How do you calculate the period of the graph? The period of the graph, you say 360 degrees divided by that number for sine and cos is equal to the period. For the sine and cos graph, it's 360. Because you know, one complete sine graph makes its appearance every 360 degrees. One cos graph makes its appearance every 360 degrees. One complete tan graph makes its appearance every 180 degrees. Good. Right, so what? We just continue this pattern on the opposite side. And there we go. That's one complete sine graph. There's your 2 sine x graph. So they can ask you the questions on this. Give the amplitude of the graph. Amplitude is maximum height. Your amplitude is 2. Give the range of the graph. Your y values from -2 to +2. Give the period of this graph. The period of the graph is 360 divided by 1, which is equal to 360 degrees. Give the domain of the graph. The domain is from -180 to 360. Or you can write it as x less than or equal to 360, but greater than or equal to -180. You can write it like this or like that. You'll get it right. So you'll get 3 marks for drawing the graph. You'll get probably 1 mark, 1 mark, 1 mark, 1 mark. So 1, 2, 3, 4, and 3. You got 7 marks there on the screen already. Right. Now they can ask you for which value or values of x. Watch this. This is very important. Where is f of x greater than 0? Let's call this graph f. We have to label it. So for which values of x, like in functions, where is f of x greater than or equal to 0? Where is f of x less than 0? Where is f of x equal to 0? Right, so you've taken this down. Let's answer the first question. Where is f of x greater than 0 means where is it above your x-axis. Greater than 0 means above your x-axis. So where is this graph above your x-axis? There. Yo. Right. So for x, there's an equal to sign less than or equal to 180, but greater than or equal to 0. Where is f of x less than 0? Where is it below? Less than means below. It's below here, and it's below there. So to answer this, x less than, there's no equal to sign, 360, but greater than 180. Or for x less than 0, but greater than -180. That's the answer for the second one. Where is f of x equal to 0? Where does it touch your x-axis? At x equal -180, at x equal to 0, at x equal to 180, and at x equal to 360. Right. There we go. Let's do a cos graph. This was a sine graph. Let's do a cos graph. So I want, now remember, so let's draw the graph. G of x is equal to 3 cos x. For x being an element of -90 to 360. Right, here goes. Now, if it was remember, if this was -2 sine, it wouldn't go 0 up, it would go 0 down. Okay, here goes. It's easy, guys. You can score full marks in your trig graphs as well. So let's go. Let's draw this. Here we go. 0, 90, 180, 270, 360. minus 90. Goes up to 3 and down to negative 3. Now, it's not a sine graph, it's a cos graph. So the cos graph cuts first. So it starts at your height, plus 3. The step of the graph is still 90 degrees divided by 1 is equal to 90 degrees, and that will give me the step of the graph. And we know 360 divided by that number, 1, is equal to 360. That will still give me the period of the graph. So every 90 degrees, so this dolphin doesn't start on the ground jumping up. He starts on the diving board. And he comes down. So he comes down every 90 degrees. He hits the water. The next 90 degrees, he'll make a change. He cuts. He turns. He cuts. And he stops on the top there. And you just continue the pattern on the opposite side. Remember, you use your y-axis as your starting point. You don't start from right behind. You start from your y-axis. And there we go. A complete cos graph. Now you can answer the questions for me. Give me the amplitude of the graph. Give me the domain of the graph. Give me the range of the graph. Give me the period of the graph. Where is f of x greater than or equal to 0? Find the function value of x equal to 60 degrees. There we go. Shh. So here's question number 1, question number 2, question number 3, question number 4, question number 5. Here we go. Right, what's the amplitude of the graph? What's the amplitude is maximum height. What's the maximum height? 3, good. The domain of the graph, there we go. From minus 90 to 360. What's the range of the graph? Lowest y to highest y. Negative 3 to positive 3. What's the period of the graph? There we did it. 360 degrees. 360 divided by 1 is equal to 360 degrees. Oh, sorry. Where is f of x greater than 0? Where is this graph? Oh, sorry, it wasn't f, it was g. Where is g of x greater than 0? Where is it above? It's above there. And it's above there. So for x less than or equal to 90, but greater than or equal to minus 90, that's where it's above. Or for x less than or equal to 360, but greater than or equal to 270. You must give both solutions. Agreed? Find the function value of x equals 60. That means where x is equal to 60 degrees. You need to find the function value. Function value is the y value. Now, they can specify, use the graph. Then you'll have to read it off the graph. Alternatively, you can just do, to answer question number 5, I'm just going to do it here on the top. I'm just going to do it on the top. The function value. So the answer to question number 5, we know that g of x is equal to 3 cos x. G of x is equal to 3 cos, they're telling me for x equals 60. 3 cos 60. Just do this on a calculator. Here's your answer coming up. Your function value, your y value at x equals 60. 3 cos 60, close brackets, equals 3 over 2, 1.5. So it's here. It's exactly halfway here. It's 1.5. 3 over 2. Your function value is 3 over 2 or 1,5. There we go. That's how you interpret these questions. And there we go. That's your graph. All right. Let's go into finance. Right. Let's wrap up. Let's do the whole of finance for the year. Yes, the whole of finance. Right, let's go, let's go, let's go. We're now doing finance. So we've done the whole of analytics. We've done the whole of functions. We've done the whole of trigonometry. We've done trig graphs. Now finance. Let's go, finance. Now, very easy. Listen to me. I'm going to give you an overview. I'll always give you a map so that we know exactly. This is the whole overview for the entire year. What you need to know. Finance, the first thing you need to know is simple interest. Relax. Right. Simple interest. Now, simple interest, your formula is A equals P into 1 plus I times N. Right. A is your final amount. P is your principal amount or your initial amount. 1 is 1. I is your interest rate as a decimal. And N is your number of years. No, number of years, not number of months. Right. So this is your simple interest formula. Where do we use the simple interest formula? Where do we use it? We use it when the question uses the word simple interest. We also use it for hire purchase agreements, HP. Hire purchase agreements. Right. That's the usage of it. Then we have compound interest. And our formula for compound interest is A equals P into 1 plus I to the power N. Very good. When do we use the compound interest formula? We use it when the question says compounded annually. And we also use it for rate. Whenever they say something is increasing at a rate, like inflation, your inflation rate of a country, every year things get more expensive. So, inflation. Or they can say a certain bacteria is increasing or decreasing at or increasing at a certain rate of, say, 15% per annum. If there were 2 million bacteria in a certain area in 2015, how many bacteria are expected in the year 2030? Again, they're using the word increasing at a rate or decreasing at a rate. It's always compound interest. And then we're going to have what we call a timeline. Now, a timeline is a mixed example of simple and compound in one question. Right? so that they'll give you simple and compound in one question. So there we go. If you know this, this is your entire finance component for grade 10. And we're going to go through everything. I'm going to make sure that by the time you leave, you're done with this. You'll get this right all the time. This is marks for jam. It's marks for free. At least 15 marks in your exam. 10 to 15 marks in paper 1. Get your full marks here. Now, obviously, they're going to ask you to change the subject of the formula. So either in a simple interest, to find I, to find N, to find P, to find A, they'll play around with what they want you to find. And they definitely going to give you a higher purchase agreement. Higher purchase, you buy this calculator or you buy a cell phone for 10,000 Rand. And then you put a 20% deposit, the balance you pay over 3 years, calculate the monthly repayment. If, for example, a 2% per annum insurance is added per month for 6 marks, do that agreement. Calculate your monthly repayment. We're going to do examples like that now. Okay? So let's go, guys. You've taken this down. Let's start off with the first component, simple interest. %. No ways. 50 for paper 1. Destination distinction, Baba. We aim for 120%. We need to know our work 200% well to get 100% guaranteed. Right, so let's start off with simple interest. So let's say Yasin, there you, right, invest 10,000 Rand and receives 14,200 after 6 years. Calculate the simple interest rate used. Calculate the simple interest rate that he received. Yeah, 6 years. Calculate the simple interest rate that was used or that he received on his investment for 4 marks. So our clue here is simple interest. So immediately we know A equals P into 1 plus I times N. Calculate the simple interest rate. So circle this. We're looking for I. There we go. Here's it again. Subject of the formula. What is this, guys? Subject of the formula. So A is his final amount, 14,200. P is his original amount, 10,000. 1 plus I we need to find times N is how many years? 6 years. We're circling I. Now make I the subject of the formula. What's the first thing we need to get rid of there? Very good. We need to get rid of the 10,000 because it's attached to the bracket. So we divide this side by 10,000. What I do on the right, I do on the left. So what am I left with? 1 plus I times 6 is equal to 14,200 over 10,000. Now, what must move? To get to I, what must move? Not the 6, the 1 first. Whatever is loose moves. Positive and negative is loose. It's a simple physics concept. Whatever is loose moves. What's stuck stays. Loose means positive or negative. Multiplication or division is super glue. That stays till the end. You get rid of that only last. So let's go. Let's move that over onto the other side. I'm moving over here. I times 6 is equal to 14,200 over 10,000 minus 1. So I is equal to, right, we take this whole thing and we divide it by 6. So now, because we now need to get rid of the 6, so we take 14,200 over 10,000 minus 1 divided by 6. So it will give it to you as a decimal. You still need to multiply it by 100 for percentage. So open brackets, 14,200 over 10,000 minus 1, close brackets, divided by 6 equals 0,07. Yeah, 0,07. So I is equal to 7% per annum. There we go. Agreed? Learn. This is how you change the subject of the formula in finance. It's the same as algebra. That's why I told you people, if you can't get your algebra right, you're going to fail everything in math. Trigonometry includes algebra. Finance, algebra. Everything, algebra. Your equations, because maths is about equations. Okay, now let's give you a hire purchase agreement. Now here they don't need to tell you simple interest. You need to know hire purchase is always simple interest. So let's make one up. Let's make one up. Okay. So let's use Layla. Layla? Who's Layla? Layla, you here? Okay, there's Layla. Okay, so Layla buys a laptop from the iStore, a laptop for 35,000 Rand. Oh, Layla got shell. Layla is up. Right. She buys a laptop from the iStore for 35. She wants a new MacBook Air. Or the entry-level MacBook Pro. So she buys a laptop for 35,000 Rand. A 15% cash deposit is required. And the balance to be repaid over 3 years on a hire purchase agreement. So she doesn't have the 35,000 Rand cash, but she's got 15% of it. Right. Calculate the monthly repayment or her monthly repayment on the loan or on the laptop if the interest rate is 13.5% per annum. For 5 marks, show all calculations. Okay, let's make it even more interesting. Let's make it for 8 marks. And a 2% per annum insurance is charged on her monthly repayment. Right, 7 marks. So there's the story. We now need to calculate how much, what is Layla's father because he's going to be paying for it. What is he in for per month? 2 rand, 5 rand. Yeah. Okay. Right, so let's do this. Let's do it together, guys. After this, we're going to do one compound interest and then we're going to do one timeline. Then we're done. Right, so let's go. In our answer, the first thing is we calculate our deposit. So here's your answer. The first thing, Layla's father needs to know how much cash does he need to put in. So 35,000 times 15%. 35,000 times 15. Let's see whether he's a happy man. 35% times 15 divided by 100. 5,250. I would swipe. 5,250 is what he needs to pay cash. So he gives his credit card or his debit card. He says, right, take that off. The balance, you work it out for me. So he says, I'm not going to pay cash. So that means now, how much does he owe them? So now we take 35,000 minus 5,250 because that was his deposit that he paid. That means his loan was 35,000 minus 5,250, 29,750. But now they're going to add interest on this. So now we say A equals P into 1 plus I times N. So now we take 29,750 into 1 plus his interest rate. His interest rate is 13,5, 0,135. Please, as a decimal, divide it by 100. Times N. Times how many years? 3 years. So only 36 months, so times 3 years. Okay, let's go. Let's see how much he finally owes on the laptop. So 29,750, open brackets, 1 plus, and this is a real life situation, guys. You can test this out. This is how they calculate even your monthly repayment on an iPhone or on a Samsung or whatever. They calculate, and that is why when you work it backwards, over 36 months, you'll find out you're paying twice or thrice the price. 0,135 times 3 years. How much? 29,750, open brackets, 1 plus 0,135 times 3 years. 41,798 rand 75 cents. Right, this is how much he owes them. But now he needs to pay monthly payments. So in 3 years, how many months? Good. So divided by 36 months. All right, there we go. Divided by 36, that gives him 1161,0708. 1161,08 per month. But that's without insurance. That is without. You still need to calculate what the insurance is. Now the 2% is on the purchase price. If 2% insurance is charged, I forgot to, so just add it in there, on the purchase price. Right, on purchase price. Now we need to calculate 35,000. Now you're not going to work it on 41,000. You're going to calculate 2% of 35,000 for the year. So let's go back. Now we need to calculate insurance. So now you calculate insurance. So 35,000 multiplied by 2%. This will give you per annum, per year. Per annum is per year. 35,000 times 2 divided by 100, 700 Rand per year. Per annum. Divide that by 12 months because it's monthly. Correct. 58 Rand 33 per month. Now that insurance is added to her monthly premium. So what will he be paying per month including insurance? Here's your answer. Here's your final answer coming up. But you got to show all the calculation. 1161.08 per month plus the insurance of 58 Rand 33 per month. What's your answer? 1161.08 plus 58.33, 1219. 1219.41. All right. Okay, no, we'll do the 50 Rand for the timeline. So, here's the last one coming up. Okay, we got two more. I'll just give you one compound interest one compound interest, and then one timeline. Right, so here goes. Okay, here goes. Right. Right. A certain bacteria increases at a rate of 8%. No. Increases at a rate. Okay, let's just put it at a certain rate because we need to calculate the rate. Right. If there were 2 million bacteria in a certain pond in 2024 and 6 years later, there was 8 billion. Calculate the rate at which they were reproducing. Calculate their reproduction rate. For 4 marks. So is it simple interest or compound interest? Compound, because it's increasing or decreasing at a rate. We got 8 minutes to go because the principal wants to say some closing words as well before we all leave. Work this one out. Work this one out. Right, so A equals P into 1 plus I to the power n. There was 8 million at the end, so we go 8 million is equal to 2 million into 1 plus, that's the reproduction rate, I, n is 6 years. Divide by 2 million, divide by 2 million. So 1 plus I to the power 6 is equal to 8 million over 2 million. Right. So 1 plus I is equal to get rid of the 6th, I find the 6th root. So that means the 6th root of 8 million over 2 million. Now, don't round anything off. You can see I'm not using my calculator yet. I will only use the calculator in my final answer. We round up nothing. Only in your final answer. Otherwise, you're going to lose. You're going to get a totally different answer. Now, the plus 1 will come on the other side as minus 1. Now, I equals. Right, let's go to our calculators. Let's say the 6th root, fraction, 8 million over 2 million, that's basically 4. Zero comma 26, 25,99, 0,2599. So they were increasing at the rate of 26% per annum. Well done, well done, well done, well done, well done. No, the 50 rands for the last one. No, the 50 rands for the timeline one. Right, let's go. The timeline, here we go. Let's see who can do this timeline. Okay. So let's talk about Trig. Right, so let's go. Here's a timeline question. Trig invests 15,000 rand for a period of 8 years. Interest is calculated at 8,2% per annum simple interest for the first 4 years. Thereafter, 7,8% per annum compound interest for the remaining period. He withdraws 2,000 rand 6 years after his initial investment. How much in the account at the end of the 10-year period? How much in the account, AC, the account, after the 10-year, or 8 years, 8 years, after the 8-year period? After the 8-year period. First person to give me the right amount, the first person to give me the right answer, win 75 rand. Make it 100. Come on. Yeah, let's just be a bit. Right, 100 bucks. First person to give me the right answer gets 100 bucks. 100 rand. Right, while you work it out, I'm also, because I made it up, so I'm also going to be working it out here so I can see what's the fun. Give me a piece of paper. No ways. Right, as you guys are, here's your 100 Rand question. We're all working it out at the same time. So, we're drawing a timeline. You can draw a timeline. And there we go. T0 is now and T8 is after 8 years. Right, so 1, 2, 3, 4, 5, 6, 7, 8. For the first 4 years, 1, 2, 3, 4. You done?
Don't shout the answer. Now just lift
Wait,
your
we'll
hand.
work it out. 8.2% per annum simple interest. 7.8% compound. 15,000. 6 years after he takes out 2,000. So 15,000 into
Someone needs to stand there. So one man.
If you've got the correct answer, write it in a piece of paper. I'll come collect the paper, give to Mr. Kota. He'll choose the correct answer, then we give out the money. But don't shout out the answer.
write it on a piece of paper, pick up your hand, put your name on it. The first person that will come here, that will give me the answer, will get $100.
Write your answer on a piece of paper. Just lift up your hand. I'll come pick up the paper. Okay. Someone there. I know your name.
Not right. Not right. Not right. Not right. Not right. Correcto mundo. Correcto mundo. Correcto mundo. No, Sumaya, no, your answer is not right. Here we go. Oh, and Nabila. And Nabila. All right, so we got two winners here. We got Nabila and we got Lukman. Right, so both online will get 100. Lukman will get 100. Well done, well done, well done. Nabila, well done. Right. Nabila, you'll just contact our guys here and send your contact details through so we can get our 100 Rand out to you. So let's do this together. Shh. So 1, 2, 3, 4 for the first 4 years. Quiet. For the first 4 years, it's 8.2% per annum simple interest. Thereafter, from year 5, 6, 7, 8, it's compound interest, and that is 7.8%. 8.2, 7.8. Right. So you put in 15,000 Rand here. So for the first 4 years, it's A equals P into 1 plus I times n. So that gives you an amount of 19,920 rand. Yeah. Guys, that gives you 19,920. Now, 6 years afterwards, he takes out 2,000. So we now need to calculate 19,920 for 2 years. So 19,920 into 1 plus I, 0,078 to the power 2. And that gives me 23,148,71. So that's 23,148,71 minus 2,000, which he withdraws. So now we get 21,148,71. And now for the next 2 years, compound interest again into 1 plus 0,078 to the power 2. Nabila, you were correct. Lukman, you were correct. 24,576 rands and 58 cents. There we go. Boys and girls, that brings us to the end of our session. All right, just sit down, stay.
Well done, Mr. Kota. Well done, Mr. Kota. So that
Thank
brings
you,
us
thank
to
you,
the
thank you.
end. Learners, if you can just be seated in the meantime, we just want to say a few words.
Thank you so much.
We would like to thank our online learners.
Well done, Lukman.
As well as our learners.
Well done. We just want to say thank you so much, guys. It's been an amazing, amazing 2 days. We've done the most amount of maths in a 2-day program. I hope you guys enjoyed it. I hope you guys loved it. And good luck for your exams. I know we've taken up your entire weekend, but I hope that it was worth the wait.
Okay, so Mr. Kota,
Nabila Esak.
we just got a few words that Mr.
Quiet.
Would just like
Quiet,
to round
quiet.
up the
We're just
program.
rounding up the program. Thank you so much.
So we would like to thank Al Azhar High School here in Athlone, Cape Town, for hosting this amazing workshop. We had a diverse a makeup of learners of various schools here across the Western Cape. And the aim is for us to have a cluster of schools that will join for the October edition of the workshop, Mr. Kota. So I'd like to extend a word of appreciation to your educators, your parents for bringing you here. Would like to extend a warm a word of gratitude to Mr. Al Azhar. We've had shifts of maths teachers and lots of the educators that have been here to support us. Would like to thank our AV team, Samit and Nasir. Would like to also thank Khalid's been doing an amazing job here with the continuity presenting and also speaking to some of the learners. And we'd like to thank you, the learners. I think you deserve
They
a round of
deserve the
applause.
biggest round of applause for sitting for 2 days.
2
Absolutely
days.
amazing.
2 days.
Absolutely amazing. Thank you all. Thank you all.
Okay,
Thank
so
you all.
learners, we will be hosting a workshop during the course of October. So look out for that. Please subscribe to our YouTube platform. We will also be sharing some more information about what Mr. Mani will be speaking. And this is about establishing some sort of a study group to support all of you. Mr. Kota, any concluding remarks before we hand over to Mr. Ashik Mani?
Now, I just want to say it's been an amazing experience being here in Cape Town. Lots of love from Awqaf and myself to all you learners, online and on site. You guys have done an amazing job by attending for 2 days, sacrificing your weekend. We know how precious your weekends are because how hectic your weeks are. So, yeah, I think I'm really looking forward to all of you producing those distinctions. I hope that this weekend there's a lot that you've taken, that you walked in, and that you're taking away with far more. Your takeaway is far more than what you came here with yesterday morning. So we've done a complete session. Remember, we're coming back again for you to support you in late October before your November exams. We'll be working through past papers and inshallah, destination distinction. I'm very confident that we're going to be pulling at least 4 to 5 100%ers from the cohort. Love you. Amin.
Okay, learners, just before we go, from outside the host of the school, I want to say thank you very much for the time that you spent, for your concentration, for the hard work. You are special. You have now gone through a maths training course, boot camp, from the best of, the coaches that you can get. Big hand of applause to Mr. Kota. Thank you very much. But you have certain skills, and you are now special. You have what the others who didn't come don't have. And I don't want you to lose the skills and what you've gained. So we're going to establish you who are here. We have your contact details, we have your cell phone numbers into a WhatsApp support group, inshallah. So you're never going to be alone. If you need help, you ask the group and the group will answer. So with the permission of the other teacher, Ms. Aisha Ali Wood, and TLC have been wonderful and disciplined. I want to thank her as well for being here the whole weekend with you and our teachers. And we are now going to form one community, one group. We're going to be called the Awqaf Maths Support Group, inshallah. Amin. So we wish you well, and you're all going to get distinctions. Amin. Assalamu alaikum. So we're going to read Bismillahirrahmanirrahim. Wal asr. Innal insana lafi khusr. Illa alladhina amanu wa amilu salihati. So bil haqqi wa tawasaw bis sabr. Amin. Go well and go safely and enjoy maths.
In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and